So again, welcome you all. Now I would like to call our first speaker.
Sir, your audio is not proper.
My voice is not proper.
Now it's okay, sir.
Okay. So I would like to call our first eminent speaker of keynote speaker, Dr. Deepankar Natsar. He joined Indian Institute of Technology, Kharagpur as an assistant professor in electrical engineering department in 2016. Prior to joining IIT Kharagpur, he has worked as assistant professor at IIT Indore and as a research associate at IIT Bombay, both at electrical engineering department. He was conferred with a PhD degree along with excellence in PhD thesis work from the Indian Institute of Technology, Bombay in 2015 for studies in power electronics and power systems. He has done his ME from IIEST Sipur, West Bengal and BE from NIT Agartala. His research interest area includes design of integrated power electronics converter topologies, design of solar photovoltaic based standalone off-grid systems for rural areas, multifunctional inverter for grid integration of renewable energy resources, study of microgrid, motor and motor control design, etc. So I again welcome you, sir, Dr. Deepankar Natsar. Thank you.
Hello. My sound is coming clear. Can you please confirm?
Yes, sir. Clear. It's clear.
Okay. Thank you for the nice introduction, and I sincerely thank organizing team because it is always a big load organizing such a big event and managing all the nuances is very difficult. So thank you for taking the pain. And looking at the current scenario, I am very sure that this topic is very relevant and will generate a lot of interest among the participants. We faculties at IIT Kharagpur, we are also very interested in this electric vehicle domain for research and development. In fact, we have few projects and several of our students are working on this. We do have decent facilities also. Due to lockdown, some things are not complete yet, but still we have, for example, we have motor test bench starting from 1 kilowatt to 100 kilowatt, so that we can cater all the ranges of different segment of vehicle. You can test your motor controller, your control logic, etc. Vehicle controller. So if you happen to visit IIT Kharagpur in near future or nearby area, please do visit our lab. And at the end of this talk, I'll be sharing my email ID, etc. So if you happen to visit us, please write to me. And if you also have any collaborative research in mind where our interests will match, please do visit us and also write to me. Hopefully, we can do some good work together. So with this, let me try to share the slide, but it appears that the sharing option is not activated. Can you please give me the access? Only meeting organizer and presenter can share.
1 minute, sir.
So in the meantime, may I ask a question? Is there anyone who has driven an electric vehicle from the audience? Can you please share your experience if you have driven anything, electric two-wheeler, electric three-wheeler, four-wheeler, anything? Have you driven any electric vehicle? Okay. Yeah, please unmute yourself and you can express.
Hello.
Yes.
Yeah, I have driven a golf cart, electric golf cart.
Okay, thank you.
Hello, sir. I had a two-wheeler.
You have a two-wheeler. Great. Anyone else?
Hello.
Yeah, I think the share just came up.
I have driven
Yes.
two-wheeler, sir.
Two-wheeler.
1 minute, sir.
Two-wheeler.
Deepankar,
Okay.
I just give the command. You can now
I got
present
it.
your screen. Yes.
I've got it. Thank you. Yeah. I'll start. Yeah. So I personally, I have a two-wheeler in my garage. That is my personal vehicle. And this electric three-wheeler or the Toto, we call it, right? Tuk-tuk is known as different areas. So that also I have driven. We have one in our lab. And just last week, I drove Tata Nexon electric vehicle also. So I do have kind of entire range of driving this vehicle, and it is pretty fun driving. For example, Tata Nexon EV, I am driving my Desire, which is a petrol car, for last more than 3 years. And when I drove the Tata Nexon EV, believe me, it was a very different experiment. This was running very smooth. It was feeling so powerful, and the running cost is pretty low. So if possible, just try to have a test ride of Tata Nexon EV or some other electric vehicle, and you'll feel the difference. Why EV is so getting so popular nowadays. Right. So with this, let me share my screen. Please let me know once you see my screen, my slides.
So it's visible completely.
Okay, thank you.
If it can be enlarged, it is much better if it is possible.
Yeah, I've given full screen, but I don't know. Some sites are missing.
Okay.
I guess I won't be able to do anything now. So let me continue. Is it visible?
Yeah, visible.
Okay. And I'm trying to write welcome at the middle. Please confirm whether you can see it.
Yes, sir, we can see.
Okay. So I'll be able to write something if I have to add. So in this talk, again, let me clarify from the organizing team. How long I can continue?
So you can go up to 12:35, no problem.
12:35, including question and answer, right?
Yeah. 5 minutes for last 5 minutes.
Okay, sir.
Okay. But I would suggest that if it is possible, can they ask question in between also if they have some query?
Yes, sir. Yes, sir.
Yeah,
Okay.
no problems. It depends on you, sir.
Yeah. I really like to interact. So if you have any question, any doubt in between, please stop me and you can ask. And so you need not wait for 1.5 hours. So I want you to make it kind of more interactive, more two-way kind of discussion. And in between also, I'll be asking few questions, and I hope that you will be able to answer them. These are very easy questions so that we can make it more engaging. Right, so let me start. And in the meantime, I request all the participants to please mute your mic. And if you have any question, unmute or type in the chat box. And organizing team members can read that for me if they're okay with it. Yeah, so please mute your mics and let me start. The topic
All
that
participants, please mute your mic.
Yes. Okay. So the topic that I'm going to discuss with today is introduction to electric vehicle and its power converter requirement. So basically, the power electronic component that you need for this electric vehicle that I'll touch upon, and overall electric vehicle architecture, all those things will briefly touch upon. So we'll talk about why we need electric vehicle, what are the pros and cons, what are the major subsystems. Then I'll take you to market survey so that you can clearly understand which motor is being mostly used in electric vehicle, what kind of control philosophy they use, what kind of battery they use. So all those things will be very clear to you. And then I'll take you to this power converter segment, motor controller, battery charger. So I'll just give you a brief introduction. I have seen in the schedule that these topics will be covered in more detail. So I'm not going to discuss in depth, just would like to give you an overview. And if time permits, I'll also talk about some interesting electric vehicle concept. For example, this one, and few more. But I'm not sure whether I'll get enough time. Maybe else we can discuss it some other day. I hope you will enjoy this 1.5 hour journey with me. And if you have any question, please ask me in between. Right. So I'll start with that. What I am referring by the term electric vehicle. So simply I'm referring any vehicle which depends on one or more electric motors for their propulsion. Okay. So if you want to drive the vehicle, you need some driving force that is coming from electric motor. Most of the standard electric vehicle will have only one motor, but vehicles like Tesla, they have actually two electric motors. Right. So vehicles which relies on one or more motor for their traction, right? So that I'm referring to as electric vehicle, and they should also have a portable energy storage, right? For example, two-wheeler, some of you have already driven two-wheeler, three-wheeler. So those will come under this category. Now, if you look at the history of automobiles, history of this kind of vehicle for transportation, you will see that initially there was a time when these EVs were actually dominating in the market. But then those petrol or diesel based car took over. But again from 1990 onward, this EV started getting more popular. One of the strong reason is of course global warming, pollution, etc. Second, another issue is that your reserve for petrol and diesel, they're going to be finished in next 200 years. So anyhow, you have to make transition towards non-fossil fuel based vehicles. So this segment, I'll try to take you to some advantage and disadvantage of electric vehicles. So first, I'll start with this very well-known statement that electric vehicle as compared to their IC engine-based vehicle. By IC engine, I'm referring to internal combustion engine, which you see in petrol and diesel car. Right? So in electric vehicles, if you just compare vis-a-vis IC engine-based vehicles, you'll see that overall carbon dioxide emission is much lesser in electric vehicles. So you can study some paper or some video on this area. But overall, the statement is that roughly, if we convert every vehicle to electric vehicle, the carbon dioxide emission would be reduced by half as compared to now. And as a result, you can understand it will help us in reducing global warming, etc. And in fact, if we can have our electricity generated from renewable energy sources like solar, wind, then maybe fuel cell, nuclear kind of solution, wind power solution, then of course your carbon dioxide emission will reduce further. Another advantage of electric vehicle is their running cost and maintenance cost is very less, right? So just to give you an example, last week, as I told, I drove an Tata Nexon EV, and that EV was, well, of course, it is not mine. So one of my friend has bought that, and he's driving it for last 8 months, and there was not a single case of maintenance. And running cost is also much lesser, especially with respect to increasing petrol price, right? So even though capital cost is higher, but maybe later on, if time permits, I'll try to show a comparison between IC engine and EV, where you can compare their cost after say 3-4 years. Or if you got, I can share you some material on that also. And this I personally experienced. When you're driving an electric vehicle, it is very smooth. You don't feel any gear change. Most of them are having very well built, and their bottom is with battery, so the bottom is very heavy, and as a result, center of gravity goes at the lower side of the vehicle, and you feel a lot of power, stronger acceleration. So if you want to reach 0 to 40 kilometer at a very faster speed, so this kind of electric vehicle is pretty good. Now they comes with very strong specifications, and overall efficiency is also better. Another important point is that electric vehicle reduce energy dependence for countries like us, who has to heavily reliant on import of petrol diesel from Middle East countries, right? So if we can generate electricity based on all our domestic sources, so we can avoid energy dependence from foreign countries. Another big advantage with electric vehicle is that it can support the grid. Basically, if you know concept like STATCOM or some reactive compensation or active filter, etc., all those things can also
Deepankar
be.
sir.
Yeah.
So what is this ICEV?
ICEV is internal combustion vehicle engine, basically. Yeah. IC engine vehicle, IC engine based vehicle. Basically, this
There
is
should
petrol.
not be there should not be, I think.
No, this is IC engine. E
Engine,
for engine.
Okay. Thank you.
Yeah. Internal combustion engine vehicle, whereas EV is electric vehicle. Okay. So in electric vehicle, you already have a battery bank and you already have a power electronic converter. So you can connect this combination to the grid. Basically, when you are charging from your AC grid, it is known as G2V, power flows from grid to vehicle, but you can utilize this power electronic converter to have power flow from vehicle to grid also. or vehicle to home. Just assume that your vehicle is lying in a rural area, assume, and there is no power in your village, but your battery still has some maybe energy left, so you can run an emergency light, fan, etc. So those kind of facilities is there with this is possible with this electric vehicle, which is not possible with your IC engine vehicle. Another big advantage is regenerative braking. So when you are applying brake, when you are driving your vehicle, then the kinetic energy in the vehicle can be restored back to charge your battery, and that reduces wear and tear problem when you apply mechanical brake in IC engine kind of vehicle, right? So this, by that you can increase your range also. So these are some of the advantage of electric vehicle as compared to IC engine vehicle. But as we understand, nothing is good at every aspect, right? It must be having some drawback. So let me share with some drawback. One of the drawback is that the drive range is very limited, okay? And that is much lesser than your IC engine based vehicles at per present for most of the electric vehicles. And that is a problem because you have to charge frequently, and while you are charging your battery, it takes a lot of time to charge. At per standard specs, it needs around 4 to 8 hours, right, to completely charge your battery. So whereas for a petrol car, you have to just go to petrol pump and refuel your tank in maybe few minutes, right? So this is a problem.
Sir,
But
can we charge at our home, sir, directly?
Yes. For example, this Tata Nexon EV, you can charge at your home.
Okay, that facility is there.
Yes, they provide you with a small charger, and it takes around 8 to 10 hours to completely charge. Okay.
Okay, sir. Okay, thank you.
Yeah. And some fast charge facility is also available, but that you cannot do in your home. You have to go to a charging station where you can charge vehicle quite at a faster rate. For example, now if you want to charge a vehicle at fast rate, charging does not take up linearly. Generally, charging take up faster at the beginning, and then it becomes slowed down at the end of charge cycle. So just to reach 80% of charge, let's say from 0% or 10%, it can be done quite faster, but remaining 20% takes a lot of time. So it is not kind of linear growth. So that's why just 80% capacity with fast charger, you can do it in maybe just 30 minutes. But for remaining, using fast charger, not your domestic charger. So I'll talk about it later, why domestic charger you cannot be a fast charger. What is the limitation, right? So using fast charger, you can charge your vehicle quite quickly, and you can get some additional range quickly without charging it your home. Another big drawback is the battery cost. More than half of cost of electric vehicle actually is battery cost, and it is very heavy also, this battery pack. So that is main drawback. So, and another drawback is that how much range is remaining, that is not very accurate, and that depends on actually so many factors. Your driving pattern, then what is the road condition, how many people are sitting on your vehicle, what is the age of your vehicle. Is there any disconnection?
No, sir, you are in.
Sorry, I think I got disconnected. Is it
No, sir.
okay
No,
now?
sir. It's okay, absolutely, sir.
Okay, yeah, I heard a sound that most probably it is getting disconnected. Anyway, let me continue. Right, so yeah. And another problem is this electric vehicle, as we understood, it has again started become popular after 1990. So the technology is not very mature yet, but that brings a opportunity for us to do some innovation, as that was also discussed by one of the speaker in the introductory session, that this area holds a lot of opportunities for doing some research and development work, because this is not yet mature technology, and every now and then you will see some new technique, new technology coming up. And that's why I think this FDP is very important, so that you can attend it with a lot of interest and patience. And I'm sure that you will gain a lot of knowledge. The next segment, let me introduce you to different type of electric vehicles. So one is very straightforward. It is battery electric vehicle. So what does it mean? It has only battery as energy storage element. Then that battery will be DC. And then it will be Am I audible?
Yes, sir. Yes, sir. You are audible.
Yes, sir. Yes, sir.
Yeah, actually, at the background, some noise is coming, like my M-Stream got disconnected. That message is coming. I don't know why it is.
We'll inform you, sir.
Participant,
We'll
please
inform you.
mute your
Very
mic.
sorry for the interruption. Maybe some network issue. Right. So first category is battery electric vehicle. We have battery in the vehicle as the energy storage, and battery will be DC. And as I will take you to the market survey, you will understand that most of the motors that are used are three-phase AC. So we need a DC to AC power electronic converter for driving the motor. And how do you charge the battery? We charge it from external power supply. It could be AC or DC. Generally for slow charger, domestic charger, it will take power from AC. There will be onboard charger. For fast charger, your DC will be directly connected to battery. There is no onboard charger. Fast charger has to be always off board. Right.
So now you are disconnected.
Devnath, sir. Sir is, I think, completely disconnected.
Yeah. He will be back soon. Please wait.
Thank you, sir.
Can you hear me?
Yes, sir.
Sir, temporarily you were disconnected.
Yeah, I don't know why this is happening.
Maybe network problem.
Yeah. Is it audible now?
Yes, sir.
Okay.
Yes, sir.
So what I was trying to discuss is this battery electric vehicle has some problem that they have a lower range, then slow charging time, right? Then if you want to increase the range, you have to increase the battery size. So your cost goes up. So how do you solve this issue? What could be solution to this? Can anyone tell me maybe what solution you think would be better to solve these issues? Any suggestions?
One more source, sir.
One more source, okay. So one option is add one more source. Example?
You can have a hybrid vehicle kind of thing, engine charging the battery, engine running the generator charging the battery.
So maybe you're talking about petrol, diesel, right?
You can have one petrol engine or diesel engine running the generator and charging the battery while it is moving.
Okay. Anything else? That's a very good suggestion. Anything else?
You can have battery with a long range. You can have better batteries.
Better batteries. Okay.
And
Hello?
facilities
Yes.
for charging while moving or parking.
The efficiency of the battery may be increased for longer times.
Okay. That I'll say coming under this better battery technology maybe.
Solar
Right.
charging.
Solar charging.
And also additional battery. It's possible.
Additional battery. Yeah. Okay. Any other different? So one suggestion I received is charging when it is parked, right?
Yeah, sir.
Charging while moving.
Charging when it is parked, then charging when moving, right? Right. When moving. So we call it dynamic wireless charging, technically. Dynamic.
Yeah,
wireless.
dynamic.
Let's swap batteries. Battery change. You can have charge battery replacing the
Good.
Charging in standstill position also, sir.
Yeah.
When it
This
is parked.
Yeah.
In open
This is written
place.
under this. Charging when it is stationary, when it is parked. Swap battery, yeah. Anything else?
Increase in charging infrastructure.
Charging infrastructure, yeah. Charging, good. I'm very happy that you are coming up with this suggestion, which is really good. I appreciate. Charging infrastructure improvement. Anything else?
Vehicle to vehicle charging.
Vehicle to vehicle charging.
Okay, B2B charging, good. Okay, anything else?
You can reduce the load by having the better generator.
Regenerative braking, sir.
Regenerative braking, actually most of the electric vehicle already has. Otherwise, EV won't become this popular.
Okay.
So,
You can have efficient motor or generator which can have less load on the battery, have more range.
so more efficient subsystem.
Yeah.
The motor controller. This is very good. So you see, it so many things can be done, right? And if you just do a brainstorming, even more point will come up. For example, instead of this petrol and diesel, you can think of fuel cell from hydrogen basically. Then for a country like India, you can think about methanol. Maybe we talk about CNG, LPG, right? So the point I'm trying to focus, share with you is that if you just sit maybe in a group of 5-4 people of like-minded personality, and you just do brainstorming, you'll come up with different solution and very interesting solution, and that's how you can do research collaboration, right? I'm happy that yeah. Anyone want to add anything else to this? I think we've got a very quite in a wide range of answer. That is very good. Right. So we talked about battery electric vehicle, and as already you have suggested, we can also have hybrid solution. Now under hybrid solution, in addition to battery, you have an additional energy source, maybe petrol, diesel, right? So some example I've noted over here. I'll be sharing with the slides, so you need not note anything now, right? Don't spend time on writing. Another category of plug-in hybrid vehicle is that basically you are charging the battery from external world. So what is the difference with normal hybrid solution? Here battery is charged only due to regenerative braking. There is no external source charging your battery, not. But there is a category called plug-in hybrid vehicle where you can charge your battery externally as well as through regenerative braking. So this is that category. One more category is fuel cell hybrid vehicle, right? So basically what it has, a hydrogen tank, a very compressed tank where you have to put hydrogen in a compressed kind of environment. So basically you have a hydrogen fueling station like petrol. And there is a concept called fuel cell. So it takes hydrogen from the tank, oxygen from the air, and combine them together, generates electricity plus water. So you can understand it is a kind of a clean source of energy, and that is used to charge the battery. In fact, if you don't use battery, that is also okay. But fuel cell is a very slow kind of conversion process. So you cannot get high performance like higher acceleration, higher regenerative braking, sudden charge. So those fuel cell cannot take. So that's why a battery is added to take care of all those. Sometimes people will add a ultra capacitor or super capacitor kind of solution also. So this example is Hyundai Tucson and then Toyota Mirai. This comes under this fuel cell hybrid vehicle. In fact, in India also, you will see that Tata and ISRO, they joined up together and a fuel cell bus is already developed, and it is actually they are now doing tests run on Indian road. So this is in nutshell about this different vehicle. So battery electric vehicle we talked about. Tata Nexon EV is an example, right? Then plug-in hybrid vehicle, you can charge battery externally, plus you have a extra energy source. Then hybrid electric vehicle, P is missing, right? So basically there is no plug-in option, no external charge. Then this fuel cell category. Of course, under this hybrid electric vehicle, in addition to petrol and diesel, you can add other sources, right? Maybe CNG, LPG, or any other source which is valid. Under this hybrid electric vehicle, there are different categories. For example, one is straightforward series, as some of you already suggested, that we have the engine. So you have petrol tank that goes to an IC engine, right? That IC engine gives you power in mechanical domain. So you convert it to electrical power using a generator. Then you charge the battery. So everything, this power flow happens in series. Using battery, you drive a motor. That is very straightforward, very easy to do. It's a series vehicle. But efficiency will be very less because you just think from engine to finally wheel, so many stages are there in between. How do you solve it? You have a parallel kind of architecture. So here engine is directly driving the shaft, motor is also driving the shaft. So their torques are coupled together, right? Now here exists a lot of research challenges, that how much torque you should take from IC engine, how much torque you should take from the motor, how do you optimize them, all those energy management. This itself is a good research area. And one more category is you combine them together, right? So sometimes it can flow through parallel path, sometimes it can actually flow through series path. So depending on your best optimization technique, you can choose between these two. This is very complex. But you know, when there is more complexity, there is scope for more research, right? And you can publish paper or something. And under this hybrid electric vehicle category, so we understood that maybe petrol and diesel will be there, then battery will be there. But depending on what is the size of your battery and what feature it should provide, you can categorize in different segments. One is micro hybrid. Here you can see that battery and motor rating will be much lesser. May I request all the participants please mute your mic, and you can unmute when you are answering a question. So after micro, there is a mild hybrid. So you can see that motor rating has gone up. And there comes a full hybrid, where basically it is the size of motor battery pack will further be more. But how do you differentiate between them? How do you compare? So micro hybrid, as we understood, their rating will be much less in battery and motor. So they cannot run the vehicle on their own. They can maybe just start and stop the engine. I think someone has turned on the mic by mistake. Can you please check and mute your mic? Okay, thank you. But if you see the full hybrid, you can see that the battery and motor itself can drive the vehicle, right? And it can assist the IC engine also. But whereas, for example, a mild hybrid, it cannot run the vehicle on its own. It can assist the IC engine. So based on this, you can categorize them together, and you can compare them. Another comparison can be made with respect to only battery electric vehicle, hybrid electric vehicle, and fuel cell based vehicle. So this comparison, I have just set it here. You can, in your free time, you go through it and you'll understand. There is nothing to discuss much. Right. Let me check the time. Yeah, it is 11:25. So now I'll take you to the overall architecture of an electric vehicle, and slowly we'll start understanding the physical component also. So if you are a driver driving that electric vehicle, how would you give command to your driver?
I'm having one basic clarification doubt.
Yes.
Can you please? Like in the case of electric as well as a hybrid electric, the difference we are going to have IC engine, right?
Yes.
Shall the motor be common for that is for hybrid vehicle, hybrid electric vehicle?
Yeah, for hybrid electric vehicle, you also need a motor. Battery electric vehicle, definitely you need. Right.
Hybrid, I need two separate motors, or the motor is going to be common for IC engine as well as for electric.
Okay. Actually, this I think if you talk about IC engine, what it does, it takes petrol as fuel and gives you mechanical rotation directly. So with this, you can directly drive your vehicle. You don't need any other motor, right?
Yes, sir.
Is that clear?
Yes, sir. Yes, sir.
Right. So for hybrid electric vehicle, you will have a single motor to convert your battery storage energy to mechanical rotation, and one IC engine. So one IC engine, one motor. Okay. And battery electric vehicle, you need one motor.
Okay. Thank you.
But sometimes what happens is that one motor capacity is not good enough. So you add one or two more motor. For example, Tesla is doing that.
Thank you, sir. Thank you.
Right. So now I'll take you to the major subsystem, and I'll try to give you a feel of how you as a person driving the vehicle, what you will come on. So as a driver, as you do, you will press accelerator, you will press brake, and you will control the steering. That is the main role. Steering you will regulate so that you can change your direction. Accelerator you will press so that you want to go faster. And brake you will press, you have to apply, go slower or apply it to stop the vehicle. But all this command, these are actually some mechanical command, right? We have to convert them into electrical command. So what do? You have some sensor which converts your degree of pedal or your accelerator or brake. It will sense the degree, how much you have pressed. Based on that, it will generate suitable electrical voltage signal to your motor controller. So motor controller will take energy from battery, which is DC. It will convert it into AC and give to your motor. Okay, and that motor will finally drive your wheel. So here also some component will be there. I'll discuss you in the next slide. So you'll see that most part of the battery actually goes for driving the motor, but some part of its energy should also go to auxiliary power supply. For example, in your car, you'll be having air conditioner unit, some music system, right? Then the display unit. So all of them need some energy. So from battery pack, those energy should come. In fact, all the steering nowadays, these are power steering. So there is a small BLDC motor which actually rotates the steering based on your hand rotation. Right. So if I ask you a question that what do you think, which motor is most popular for electric vehicle, which is most suitable for electric vehicle? What will be your answer?
Either PMSM or induction motor.
Okay, one answer is PMSM, two is induction motor. Any other?
Motor.
DC motor brushless.
DC series motor.
Brushless DC.
DC motor, sir. DC motor.
One is
DC
DC
motor.
series motor, conventional DC series motor. Another is brushless DC motor. Okay, any other?
Reluctance.
Switched reluctance, SRM, right?
Yes.
Switch reluctance.
Okay, any other?
BLDC motor.
BLDC is already discussed. Okay, well, very good. Let me tell you the market on this. First, DC series motor, it is not at all used. BLDC motor is used typically when your motor power rating requirement is less than 5 kilowatt. For example, electric two-wheeler, those e-rickshaw, auto, etc., they use BLDC, right? But for electric vehicle which need much higher power, BLDC is not used. PMSM, which is permanent magnet synchronous motor, is number one choice. Induction motor, as of now, it is the second choice. SRM is not yet popular, but there is a technology called SYRM. This is synchronous reluctance motor, whereas SRM is switched reluctance motor. But this SYRM, synchronous reluctance motor, that is also not directly used. They add some permanent magnet to it. They call it PMA SYRM. What is it? Permanent magnet assisted, that is PMA, synchronous reluctance motor. Tesla's new model is using this, and a lot of now industry, they are actually targeting it after Tesla. In fact, we also have designed for this both of this SRM and SYRM, and most probably we are going to fabricate it soon. We actively worked on PMSM also and BLDC as well. So our design BLDC is already being tested on the road, right? We mounted it on the e-rickshaw and it is running pretty good. BLDC is motor controller. These are running on road, not commercially, tested under within the campus kind of scenario. So hopefully in next 5-6 months we'll be able to put it on road also in a practical mode. So from that experience, I'm giving you this data, of course, right? These are some efficiency figure where you see from battery to motor, everything cannot be right 100% efficient. In fact, some of you already suggested that this component has to be more efficient if you have to increase the range. So you can just note down this number to understand state of art efficiency. What is the motor efficiency? What is the motor controller efficiency? Battery charger efficiency? So that you can work on them and you can improve them further. Right? So this will help you In fact, when you're developing a kind of simulation model for the vehicle, so there you should not assume all component ideal, right? So if you want to have this data, you can note down these numbers. Okay, so till now I tried to give you mostly on the electrical side aspect of the vehicle. Now I'll take you some mechanical component part so that this overall structure is pretty clear to you, those who are not familiar. So first I'll introduce you to the term powertrain. Okay, before that, just try to understand two more terms. One is propulsion. When you are pushing something, okay, that act is basically propulsion. For example, your motor has to do some work so the vehicle get forward or reverse movement, right? So that is technically we are calling it propulsion. And what is powertrain? So for moving the vehicle, you need some energy storage element, right? Either as a human you push it, or there has to be some petrol or battery which energy will be stored that you convert into mechanical domain. So this entire process of your tank or storage to finally mechanical power at wheel. This entire segment is known as your powertrain. Okay, so what is there inside? Let us have a look. If you talk about IC engine vehicle, right, which we are very familiar because most of us is driven that. First, you have that petrol tank and the IC engine itself. IC engine, plus of course petrol tank or diesel tank. Then there is a thing called transmission. What is there inside transmission? Basically, this gear arrangement. So those who have driven bike or car, they know you have to change your gear, right? So that those arrangements are actually mechanically there inside this transmission block. After that, you see there is a long rod. So that is known as drive shaft. Then there is, you can see there is a circular kind of component that is known as differential. And finally, the differential is connected to the wheel through drive axles. Okay. So these are the major component in a powertrain of IC engine vehicle. What will be there in EV? You don't have IC engine for a pure battery electric vehicle. Instead, you will have a motor. Okay. Now, so if you want to club them together in a pictorial manner, so first I have the vehicle power plant. Either it will be IC engine vehicle or your motor. Then comes this clutch. What is the role of clutch? When you are changing the gear, right? So already your motor is or your IC engine is rotating at some speed. Now you want to change the gear. So if you connect two bodies together, there will be mechanical wear and tear problem because your the next gear that you want to put, that is still in stationary zone, right? So one rotating zone, one stationary zone. If you want to connect, suddenly there will be a lot of problem. So what we do, we disengage the engine first, then change the gear, okay, and then put them together. But still there will be a lot of problems. So some vibration will come, some jerk will come. So minimize that. Some advanced features are already there in the clutch so that you can remove those jerk, etc. So basically, clutch is required when you are changing the gear. Please note that. In most of the electric vehicle, it will be fixed gear. Basically, one set of gear, one gear. Okay. So then you don't need to change gear. So you don't need clutch. In fact, those who have ridden any automatic drive vehicle, right, or manual gear change is not required. You see, there is no clutch in the vehicle. So the vehicle I am driving is from Maruti Desire auto gear shift. So it doesn't have a clutch at all. Tata Nexon EV, it don't have any clutch. So what you have in the pedal is just accelerator and brake. There is no clutch at all because you don't need to disengage your engine, right? So clutch is not required for EV, most of the EVs. Then comes this differential. What is differential? Can anyone quickly tell us why you need a differential? Anyone?
To have different speeds on both the wheels.
To control each wheel.
No, to have different speeds while turning.
Yes, yes. So this doubt I also had at the beginning. If I have two wheels, if I just put a motor directly on the wheel, what will happen is that both the wheel has to rotate at the same speed. which is same as your motor speed, right? That is good when you are going straight direction. Both the wheels should rotate at same speed. So one motor driving them, no problem. But as soon as you want to take a turn, your outer wheel has to rotate much higher, right, than the inner wheel. If you connect a motor on both the wheel directly, then both the wheel has to rotate at same speed. So then you won't be able to take turn. So that's why this differential is used, which allows for both the wheel to rotate at different speed. So that is required in EV also.
Sir, I have a doubt. Sir.
Yeah.
Sir, if you have two different motors or different wheels, can't we control electronically different speeds of the depending on the curvature? Can we control differently?
Exactly. So this configuration I'm going to discuss. It is one of the, yes, I agree. I'm going to discuss this. Very good for your.
Sir, excuse me, one more question I have. Sir, my question is, if we want to retrofit a IC engine based vehicle with as an electric vehicle, so the main component we are replacing is only instead of IC engine, the as per your diagram. So is there any other thing we need to add?
Yeah, it is. Yeah. Please continue.
So if we want to retrofit, so we are removing the IC engine and we are putting the motor. Apart from that, is there any other component we need to add? Battery, of course, we'll add. In this mechanical components which you have shown, is there any other thing we need to remove or add?
No, basic structure remains the same, but you have to kind of customize it. For example, clutch you don't need, so why you want to put it? All this gear arrangement, 5-6 gear, you don't need. Generally, when selecting the motor for your vehicle, even if you want to do retrofit, I'll be selecting a motor which has a wide torque speed range. Okay, so then I don't need these things. What is the problem with this thing is that, mechanical things, there are a lot of wear and tear problem, efficiency reduction, all those things will come. Okay, so we don't want to keep them. They will increase your volume, increase your size. But there are otherwise, most of the things you can reuse, provided that your motor shaft is having similar size of your IC engine vehicle shaft. Otherwise, you have to do some coupling arrangement, right? I think if you have done in machine lab, you know this. Two motors, when you want to join them together, there has to be suitable coupling. So those things you can do, and you have to do some changes here, right? Plus, you can remove. Unnecessarily putting extra thing will reduce your efficiency and range, right?
Yes, sir.
Sir, I have a doubt on that, sir.
Yeah.
So in case you remove the gearbox at clutch and have just a drive from the electric motor to the differential, and you're saying that the torque speed characteristic is given by the motor itself. Motor can create a torque required for the requisite speed. So what is the mechanism which is controlling the torque and speed? Is it the character of the motor only, or is it something there's a control required for that? So where is the torque depending on speed?
Can I answer this maybe just after 3-4 slides, because these things will be discussed.
Okay, okay. Thank you.
One more point I would like to clarify: EV does use a gear, but it's only a single gear. Okay, it's not a number of gears.
Okay.
And how do you control entire speed range is from your motor controller. So I'll take you to that. Don't worry. But I'm not sure that I'll get enough time. I'll take you to that. Yeah, in just few minutes.
Thank you.
This I'll skip. I already talked to you. Maybe. Yeah. So now if I ask you to do some mental exercise, okay, visualize it. Let's say I give you a scenario. There is a level road, plain road, and a vehicle is standing. Ideal. Okay. You want to push the vehicle. Okay. So what present scenario? Let's say I want to draw this car. I have speed on one axis, speed of vehicle, then torque or force rather. Because when you are pushing the vehicle, actually it will be giving force, right? Not torque. Vehicle is at 0 speed. So if I want to draw this car, that from starting of the vehicle, as now if I give very high push, vehicle will start moving. After some time, if you want to increase the speed, so how this car will look like? Will it look something like this? Or it will look something like this? What do you think this car will look like? Do you have any idea? Just visualize it. Vehicle is at stop condition. You have to give it a push at different speed. How much push you need?
Linear, sir.
So you think it will be something like this?
Second, sir. Second, yeah, like that.
Okay. Or someone may say it may look something like this, right? Someone may say it looks something like this. So how do you just try to visualize it? You will understand why I'm telling this. Any other answer apart from, so I got one answer on this. Any other answer? So I want you to think in this point, maybe forget about vehicle, you're driving a bicycle. What happens is that at the initial you have to give slightly higher push, okay? But at the vehicle starts moving due to its kinetic energy or momentum, your force requirement comes down. But what happens after some time, it starts again increasing. Because when your vehicle is moving, a lot of opposing force will try to restrict its movement. You must have heard about rolling resistance, then aerodynamic drag. So this aerodynamic drag, basically wind is opposing your vehicle, that is proportional to vehicle speed square. So after some speed, that this aerodynamic drags become quite dominant. Okay, and this is how typically the torque speed curve of a tractional load looks like. Initially, you need high push because it is at steady level. You have to give more force to make it run. Then, as speed develops, torque requirement comes down. But after some time, your opposing force increases as a vehicle speed square. So this is how typically the torque speed requirement from a vehicle looks like on a flat level. Right. Okay. So now let us try to see why gears are required. So all those who have driven IC engine vehicle would know that we have 4 or 5 gears in IC engine vehicle, right? Generally, the fourth gear is having gear ratio very close to 1. Okay. So these solid lines you are seeing here, these are for IC engine vehicle kind of scenario. And fourth gear means gear ratio 1, so basically speed torque is more or less same. So this you can consider to be the torque speed or force speed curve of IC engine vehicle. So you can see it cannot give high starting torque, but if you just extend it, this zone it cannot operate. So that is the reason that you put some gear. What is the role of gear? So by putting different shape of gear and size of gear, you can increase torque or speed, and that will be vice versa. If torque increases, speed comes down, right? If you put different gear. If you want to reduce torque, your speed will go up. Because overall power has to be same, right? If you neglect efficiency. So in mechanical domain, power is torque into omega, right? So if you want to increase torque, your speed has to come down. So initially, at low speed, I want more torque. So I'll be putting first gear. It will give me higher torque, right? This one, and low speed. Then as speed develops, I'll change to second gear. That will give me slightly lesser torque, but more speed. Then as I want to go for high speed, I change it to third gear, fourth gear, and so on. So this is how IC engine needs gear. But look at this dotted curve. This is torque speed envelope for a motor. And you see, it is inherently there. Okay. Most of you who have studied electric machine, you know there is a zone called constant torque zone, constant power zone, right? So this curve should be very familiar with you. When you look at this, it quite matches this. Of course, at very high speed, you are not going to, your vehicle will be having a maximum speed limit, right? You don't go to 1000 km per hour. So if you just match this to this, they look quite similar. Okay? That is the reason we don't need so many gear in electric vehicle. Hardly we need maybe 1 or 2 gears so that you can match the closer requirement. For example, your motor cannot have that much of torque requirement. So you just put in one single gear. Just to give you some number. Yeah.
Sir, you said DC series motor is not used in case of these electric vehicles.
Yeah.
So if you see this torque speed characteristics is almost the torque speed character of DC series motor.
Yeah.
So
let
initially
me
we need high
please
starting
continue.
torque.
Please continue.
Initially we want high starting torque, right? So if you go for DC series motor, it will be better, no, sir?
Yeah. Yeah, in fact, if you remember that in train, etc., DC motor, series motor was very useful in the beginning. But DC motor has so many drawbacks. It needs a lot of mechanical maintenance issue due to those commutator and brush.
Commutation
Right?
brushes, right?
Then also it cannot go for very high speed. Then your spark issue becomes very significant. So in all locomotive application, DC series motor no one uses now. They use induction motor mostly. Okay. And let me clarify again. This I am talking about is the torque speed capability curve. It is not the torque speed characteristics. For example, induction motor, you must have remembered this kind of curve. That is your torque versus speed curve, characteristic curve. But what is the capability of the motor? That looks something like this. Okay, torque speed curve. What it signifies at this point, at different speed, what will be the maximum amount of torque your motor is able to give? Okay. Whereas this curve, it is defined for a given voltage and given frequency, given supply. For induction motor, this curve is defined for rated speed, rated voltage, and rated frequency. And you must be knowing that induction motor can be operated with V by F control or field-oriented control, where I can change supply frequency, right? So if I change my reduce supply frequency, my curve will look something like this. Then this. So what it signifies that if I want to operate at this lower speed, my maximum torque that motor can give is actually this, not this one. This one. Right? So this, if I join what is the maximum rating your motor can provide at different speed, that is this curve. We call it maximum capability curve or envelope, which is true for different speed range. So that by default, most of the motor has this curve. So that's why we don't need much of the gear, like I see. Those who are not very clear about this, I like to draw it again. With respect to induction motor, this is your speed torque curve. But this is valid only under rated voltage, V-rated, and frequency rated. If I do VYF control, my curve changes like this. Maximum torque remains the same at different speed. Okay? But beyond that, actually, it goes like something like this. So just look at VYF control technique for induction motor, then you'll understand what is this envelope I'm. So yeah, next time there is even 45. Okay. Yeah. So we have a motor. I'm now trying to tell you different powertrain configurations possible and some research solutions. So generally, if I have a motor, I need variable gear. Like say I need 2-3 gears. Then I need the clutch. Okay. May I again request to mute your mic, please, all of you. Here, but thank you, thank you. So if your vehicle needs more gear, then you need this clutch arrangement, and this D is for differential. But if you are using a fixed gear, only one gear, then you don't need that clutch. You see, motor, fixed gear, differential. Next solution is that these components are kind of separate component. You attach them together. Can you come with a single solution? Very integrated solution developed in a single package, right? So it will make your life much easier. Design is complex, but once you have done it, so this is known as transaxle. For mechanical engineering aspect, this is in fact a very good research area for electric vehicle. Next solution, can you remove the differential? As some of the participant has suggested, if I can rotate both the wheel by two individual motor, so then I don't need differential, right? Because I can control both of them at different speed at per my wish. So this is that solution. Differential is removed. Next is, if my motor is sufficient enough to give me desired torque speed curve, the gear is also not required. So if you can design a motor such that your gear requirement is not there, it can provide you a very wide speed torque range, then you don't need the gear at all. You can just put your motor inside your wheel, right? and you can do all this. So these are the different various opportunities where you can build your electric vehicle model, you start doing control, you design the motor, fit it inside the wheel, do hardware experiment, and maybe someday you can come up with your own startup. As Professor Praful Kumar Udani sir was speaking at the inaugural meeting, right? That what is the Indian startup doing? Maybe some of you can actually start doing this. This is not yet commercially available for electric vehicle. Some buses are having it, not directly though. They are having a different architecture. So this solution is not yet still there for low-end vehicles. So if you want to do it for four-wheeler, maybe your startup can be very successful, right? Okay. So here I need your attention, and it is again a very important visualization. So sometime as soon as we talk about motor, two things come in mind is one is torque, one is speed. First question is, I want to decide a motor. I want to select a motor for my four-wheeler. What should be the torque requirement? What should be the speed requirement? How do you know? Or how much battery you want to use? How do you know? Right? So all this sizing related problem can be easily taken care by doing some simple MATLAB simulation. Okay. So I'm not going to discuss all of them together. If you want, I can have a separate session on this. How do you size your motor for two-wheeler, three-wheeler? All these things can be done very easily. But to start that, you need to visualize, you have to feel how much torque is 1 Newton meter, right? All of us know that 1 Newton meter is the unit of a torque. But have you visualized ever what is the, how much is 1 Newton meter torque? For example, if I say you what is the 1 kg of sugar, you know, right? Because you have went to market several times, you purchase 1 kilo of sugar. You will feel that, you know, this much of sugar, I feel 1 kg, right? But what is 1 Newton meter torque? Can you visualize that? Is there anyone who would like to answer this or to share something on this? Question is, how do you visualize 1 Newton meter torque? Kitna hai? How much is that? Any idea?
Sir, 9.8 Newton is equal to 1 kg. 9.8 Newton is 1 kg.
9.8
Newtons is 1 kg.
Okay.
So you can say 1/10 of a
but
kg.
This is force, right? Sir, this is force.
Exactly, this force. I'm saying this force.
Weight.
Exactly, force. I'm going to that. So that means 1/10 of a kg is almost, you can say, 1 Newton force.
I see. This is. I'm sorry to interrupt. This does not go with the formal definition of force, right?
No, definition of, you can correlate the units. So you know that 9.8 newtons is equal to 1 kg. That means almost 1/10 of a kg is equal to force of 1 Newton. Okay. And that applying at the length level of 1 meter, that will cause you to a 1 Newton meter torque.
Okay, excellent, excellent.
So that is, you can just visualize the how much will be the, you know, if you put a weight of, I can say 1/10 of a kg, that means 100 gram at 1 meter, that will produce a torque of 1 Newton meter.
Excellent, excellent. Yeah, very good. In fact, I was going to discuss this. Right. So let me just quickly repeat it with some diagram, maybe just so that the audience can also visualize it. So if we have, what is the definition of force actually? You know, from Newton's second law, force is mass into acceleration, right? So if I have 1 kg of mass and you want to push it such that it attain an acceleration of 1 meter per second square, that is 1 Newton, right? As Professor has already mentioned, 1 kg of some mass, if you want to have 1 meter per second square acceleration, you have to push it such that, so that force requirement is 1 Newton. Okay. What is torque? Torque is force into distance. For example, if you have a screw, you have a wrench to rotate it, right? So you are providing a twisting force here. When you're trying to tighten the screw or loosening the screw, you're doing a twisting force. That itself is actually torque. So that force you are applying here, then into distance, that is torque. So how do you visualize, as Professor told, that is very, very, very relevant example. If you have a 1 kg of apple, okay, sorry, 1 kg of apple, typically, sorry, not 1 kg, sorry, 1 piece of apple, typically that will be 100 grams in more or less. And your hand, if you stretch your right hand, that will be roughly 1 meter. Let's say this is your shoulder joint. This is your complete hand, okay. This typically will be 1 meter. So you are holding 100 gram, and due to gravitational force, this apple will experience a acceleration or force in this towards earth, right, due to gravity. How much is that? That is 9.81 meter per second square. Okay. So this will be the force experienced at this point at the apple, and that into distance, this is 1 meter. So in a shoulder joint, the amount of force you will experience is kind of 1 Newton meter. What is 1 Newton meter? Basically, this 100 gram into 9.81, that is make it kind 100 gram is basically 0.1 kg, right? So 0.1 kg into roughly this, if you take around 10, so that is 1 Newton, and then this meter due to distance into 1 meter. So if you stretch your right hand, hold a apple on your palm, the twisting force that you experience on your shoulder joint, that is 1 Newton meter. So with this information, now you can visualize roughly what is 1 Newton meter torque. If I ask you this question, that this is a two-wheeler from ATAL. You know, ATAL is #1 bike. Again, it is a IIT Madras based, student alumni based startup, which now leading. But a few days back, Ola has actually disrupted the market. But otherwise, ATAL was leading the two-wheeler segment in India. Then this is the three-wheeler or Toto I was referring to several times. Okay, and this is Tata Nexon EV. So if I ask you, what will be the motor torque for these vehicles? Do you have any number? You can just think of any number. This exercise is actually fun. Don't hesitate. Don't shy to give wrong answer, right? Just think about what will be the torque requirement for this vehicle, this motor rather. Any idea? Okay.
Depends upon the weight of the
So roughly you assume, right? For example, let me give you some number. This will have around 600 kg.
Yeah, 125.
Carboid of this is 1400 kg. This could be 180 kg. Okay.
I think 150 Newton meter for the four-wheeler.
For the, can you repeat
please? Four-wheeler.
One, how much?
For the four-wheeler.
140?
150 to 200 for four-wheeler.
Okay. Any other answer?
And around 75 for two-wheeler.
75, okay. Yeah. I'm very sorry if I am flooding with many questions, but I thought of I try to make, I'm very sorry if I am boring you. So let me give you the number. Typically this three-wheeler, the rated torque will be around 3.5 Newton meter. Remember, I'm talking about the motor torque. There is a confusion, and they generally use a gear ratio of around 10. So you can assume for overall vehicle, it is around 35 Newton, 35 to 40. And peak will be roughly 2 times. Okay. So maybe you can assume it to be 80 Newton meter peak and 40 Newton meter kind of continuous torque. For Ether two-wheeler, the rated torque is 20 Newton. They also use a gear ratio, right? This is belt-driven motor. They also have a gear ratio. Tata Nexon EV maximum torque is 245 Newton. They also have a gear ratio of around 9.1, roughly. So you have to multiply this, right, to get the total torque of overall combination. Okay. So you can note down this if you need to further study. Okay. I'll skip through some of the content now because we don't have much time. But as I said, I'll be sharing you this slide with you. So you can understand for two-wheeler, if you open up the vehicle, where is the battery kept? Here. There will be 4 batteries in total. Two will be here, 2 will be here. Then this is the motor controller unit. This is the motor, right? You can see this is the motor. This is the differential. Okay. So you can any day you can talk to a Toto driver. You can open it up. You can see how these things are placed, how wirings are done, right? Then I gave you all this basic specification. Okay, so you can study, you can develop a model, everything you can do. Okay, next agenda is if I want to take you to market survey of commercially available electric vehicle. As I told earlier, in fact, some of you also told, PMSM seems to be the most popular choice. Okay. Followed by induction motor. You will see some of them are using induction motor, but slowly induction motor is going to become obsolete, right? For example, you see Tata Motors, they are using 3-phase induction motor, but for Nexon EV, they are using actually PMSM. And slowly, research is shifting towards PMA, SYRM or SRM also. Some of them. So this also I discussed. And battery, all of us know, mostly they'll be using lithium-ion batteries. Okay. So what is their drive range, typical mix, all this number I have just noted down here for your ready reference. If you want to study, you can use it easily, right? And as of now, in Indian market, Nexon EV is the most selling vehicle. But you see, there are so many other options that also has came up, and few more are coming up, right? So I need not elaborate it much. This slide I'll quickly skip through. For four-wheeler, we understood PMSM is the first choice, induction motor is the second choice as of now. For three-wheeler, BLDC is a main choice because the Toto, they need hardly 1 kilowatt motor. And E-Auto, they need around 3 to 5 kilowatt motor. So generally they go with BLDC. Two-wheeler, small two-wheeler, they need hardly 250 watt motor. Okay. And slightly higher powerful two-wheeler like ATAL, they need around 5 kilowatt to 6 kilowatt motor. So they are still going with BLDC. If you go with 10 kilowatt something, which is powerful bike, they go with PMSM. Okay. And this also I discussed. So summary is that most of this motor, they need three-phase power supply. Okay. For at their motor terminal. But the battery we have is DC battery. So we need a DC to AC converter, which is basically three-phase VSI. VSI is voltage source inverter. Okay. So how to derive this VSI from three single-phase inverter? Those I wanted to discuss, but I think I won't be having much time. So this slide I'll be sharing with you. So why I am showing you this slide is, reason is that when you want to come up with some new converter from your side, okay. So there are various techniques by which you can derive your own converter. So one of the technique I had tried to show you here how actually you can get it. So three-phase inverter, you don't target the problem as a very big problem at the first. You first try to divide and rule, okay. So three-phase inverter, first try to visualize three single-phase inverter, right? Three single-phase half-bridge inverter, they are controlled such a way that their phase voltages 120 degree apart. Then you realize that they are actually using the same structure for their common bus, right? Two capacitor and their midpoints are connected. So instead of using three separate capacitor leg, you join them together. So you came up with this kind of integrated solution. Next, you understand that if you are doing it in a proper control, very balanced kind of scenario, you actually don't need this line. Without this also you can control the inverter, right? So that's how this link you can break, and that's how you get a three-phase VSI. Okay. Next, of course, you can connect them in delta and all. So this is how this goes on. And how do you control? Most of the three-phase inverter, they are controlled with sine triangle PWM. For electric vehicle, I'm talking about. Okay. There exists some other control technique like 160 degree conduction or 150, 120, 180 square wave, but they are not used for electric vehicle because they have a lot of harmonics, and those harmonics, when you are feeding them to motor, it will end up with higher torque ripple, higher noise, etc. So you want to give as close as sinusoidal supply to the motor terminal, right? So that harmonics you can avoid. And that's the reason you go with technique like sine triangle PWM, where you have sinusoidal modulation indexes, you have carrier signal, you compare them together and get the gate pulse. Another technique is phase vector PWM. Okay, so these two are commonly used. Sine PWM is quite easy to implement, right? And this is also quite used. And but to implement, to get, see, most of the PWM techniques, your carrier waveform is always fixed. Okay, you don't play with the carrier waveform. Amplitude fixed, frequency fixed. What you vary is this modulating signals. So who gives you this modulating signal? that comes from your speed control or torque control loop. Okay, and what philosophy you use there for controlling? You may use field oriented control or control like VYF control or director control, right? Direct torque control. So these are the speed control philosophy which sets up this modulating signal for you, and these are the PWM techniques by which you generate gate pulse finally. For electric vehicle, generally field oriented control is most popularly used. And I saw in your schedule that one lecture is fully dedicated for that field-oriented control. So I'm not going to discuss anything on this, but I have just noted down few slides which you can refer to if is required. Okay. Now here comes a big challenge. Let's say this PMSM. If I generally this is one of our Viva question, and we sometimes ask in our theory exam also. Let's say you are going to use a PMSM whose line to line voltage is 400. Line to line VRMS. Okay, fundamental component. We are not talking about harmonics. Then this DC bus voltage, how much you need? For what minimum value you need? Can I have 200 volt battery to get this 400 line to line? No, it is not possible, right? So you follow some standard formula. This is for sine PWM. So this VDC requirement will come from what is your required line to line voltage. So you put 400 here, divide by this 0.612, divided by MA. MA is the modulation index, right? Most of you know for PWM strategy. So MA practical range, maybe you'd like to keep it 0.9, 0.95, something like that. Maximum achievable value due to practical constraint. So that's how you can calculate what will be VDC requirement. So VDC minimum, if you are using sine PWM strategy, that will be 400 line to line by 0.612 into 0.95. This is ideal. This much is bare minimum requirement. But you know there will be some voltage in the switch. When high current is flowing through the switch, there will be some voltage drop. So if you want to consider it, then you add some maybe 20-30 volt extra margin. Okay, so this is the minimum battery voltage requirement for driving a 400 volt line to line. Of course, you can have a different motor. Maybe sometime you need 200 line to line. What I am trying to say is that you have to do this design consideration when selecting a motor, when selecting battery pack voltage. So now let's say I came up with this number that my DC bus voltage requirement is 700 volt. So how do I get 700 volt battery? Is it very straightforward? No. You have to connect so many cells in series to build up, right? For example, if you talk about lithium ion battery, one cell voltage will be around 3.4 to around 4.3 volt. One single cell. Okay. So you understand how many you have to connect in series to get 700 volt. Too many of them have to be connected in series. What is the problem? Charge equalization problem. Your BMS has to be very complex, right? A lot of issues are there. So if you don't want to use such a high battery voltage, what you generally do, you connect a kind of step up converter so that you can use a low voltage battery. For example, you can use a boost converter, right? And maybe you can use a 350 volt battery or something. Tata Nexon is using 320 volt battery. Okay. So depending on your availability, depending on requirement, you have to do this design choices, right? And this boost converter has to be bidirectional because you want to do motoring as well as regenerative braking, right? So this VSI by default, it is regenerative braking capable. It is by default bidirectional. So this DC-DC converter, if you are using, this also has to be bidirectional. But again, if I ask you the question whether this is mandatory to use a DC-DC converter, it is no. Right? If I have sufficiently large battery or my DC bus voltage requirement is less, I don't need this bidirectional DC-DC converter, right? But VSI is mandatory. Okay.
Sir.
Yeah.
Instead of having this two-stage conversion, nowadays jet source inverters are more popular. So if you go for jet source inverter, it will be better, no, sir, because you can avoid dead short circuit. No need to go for dead band circuit. There are many advantages.
Yeah. So
even from
do you
IIT,
remember how many extra components are required for Z source inverter?
Depending upon our voltage variation, you can use single inductor, single capacitor also, but you should have no need to have some switching devices, sir.
Okay. See, yeah, I agree with your answer, right? I'm not going to directly oppose you, but we have in our mind this idea that if I can avoid using a power electronic device and I can compensate somehow by inductor and capacitor, it is good. Some people have this idea, and this is true for some application, but most of the application, this is not as straightforward. Okay, let me give you an example. Have you seen a physical inductor? What will be size? It is not very small, right? But have you seen how much size will be IGBT or MOSFET? It will be might be of this size.
Right.
So, in electric vehicle, you are bothered about size, volume, weight, all these things, right? It is not very straightforward to say that maybe ZSI will be better, right? You have to do, because this inductor has to, or capacitor has to carry quite large amount of current. To give you an example, Tata Nexon EV, motor rating is 95 kilowatt. So you can understand current rating will be pretty high, right? 200, 300 ampere. So your inductor has to carry that amount of current, right? So it will be at least of this size.
Even in boost converter also we are using one inductor, no, sir.
Yes. But here benefit is that, yeah, definitely you have to use this. Here benefit is that this inductor is placed such that this current can be continuous, right? Most of the ZSI input current is discontinuous. For some few ZSI is continuous, of course. Traditional ZSI current is discontinuous. So I'm not directly opposing that ZSI cannot be used, but you have to do a one-to-one comparison, right? And you will, most of the case, you will end up that ZSI is not at all used in EV.
Sir, I have one question, sir. Sir, are there any protection circuit that is required for, in this case, for battery deep discharging or overcharging?
Yeah, actually, there is for all lithium-ion battery, there will be BMS, right? Battery management system. So it will disconnect the battery. It will keep on giving you a message as soon as battery goes to that allowable depth of discharge. It will keep you sending messages that battery is already at deep discharge. So either you cut it, or at some time BMS itself will disconnect your battery to protect it from deep discharge. Okay.
Sir, are there any issues in connecting this bidirectional converter which is in isolated mode, or generally non-isolated mode is preferred in this case, like bidirectional DC-DC converter for electric vehicle?
Yeah, actually isolation is not very mandatory for this kind of application. For example, let's say if I was doing just connecting a battery here, between battery and PMSM, there is no isolation, right? Using a simple BSI. So isolation is not mandatory, but if the voltage gain ratio between your DC-DC converter input and output is too high, for example, if you talk about battery charger, which is connected to the grid, then their first, maybe I'll quickly go to the slide. Everything there, I need to draw to save some time. Yeah, I have a bad habit that I put on too many slides. Right. See, look at this battery charger solution. Standard solution, right, for domestic. You have this AC 230 volt grid, then a power factor correction rectifier. This voltage has to be higher than 325. 325 is 230 into 2, peak of AC supply. This one. And now if you are designing a battery charger, for example, say Toto, e-rickshaw, or this battery will be 48 volt. So this, keeping some margin, you will be making it 380 to 400 here. So this converter, this one, input is around 400 or 380, output is just 48. Okay. Here you cannot use an isolated converter, non-isolated converter, sorry. The efficiency will be drastically low. Okay. Sometimes some regulation for grid connected system, they want galvanic isolation. But if galvanic isolation is not mandatory also, then also for this application, you don't use a buck or boost converter. Your efficiency will be horribly poor. Okay. But for when everything is inside your vehicle, isolation may not be mandatory. But if your voltage gain requirement is quite high, then you go with isolated converter. But otherwise, it is not mandatory. So with non-isolated converter also, you can design a system. Okay.
Thank you, sir.
What is the time? Yeah, I think I just have 15 minutes left. So I'll quickly go through what I wanted to share you some more is that if you open up a motor controller unit, how does it look like, right? So this is an example of three-wheeler motor controller unit. We call it MCU. Okay, this is for the three-wheeler Toto. If you open up, you see how this looks like. These images are for a four-wheeler, commercial four-wheeler electric vehicle. Its motor controller. How does it look like? Okay, and this is how you control. So I was referring to this field-oriented control, but of course I'm not going to discuss. One talk is scheduled on it. And some of you already asked this question that if you want to have some protection, right? Because so many components are in electronic in nature, you have to protect. So some of the protection that you need to provide is listed over here. Sometimes battery you may connect in reverse direction, right? If you don't know about the correct color coding or you are in a hurry or different state of mind, you may mistake. You may connect battery in reverse polarity. So then your motor controller unit will get burned if you don't give any protection. There is inrush current, over voltage, over current. So for this entirely, these are very interesting actually. If you go inside this, how do you physically implement it? What is the requirement? All those things, this itself is a very interesting topic. And I generally take 1.5 hours to cover this topic itself. So let me not go into this. This is also very interesting problem. So a lot of people has this doubt that I'm using a battery in electric vehicle, I'm using a motor in electric vehicle, right? So what happens if there is a water coming into them and all, right? So the relevant protection is known as IP protection, ingress protection. So I'll just give you a number. So sometime you'll see that it is written in the product, it is IP67 protected. What does it mean? So this first digit is for protection against solid. For example, the motor I showed you, right, below the three-wheeler. So that is exposed to environment. So it has to be dust proof, right? Otherwise, it won't be able to operate. So that IP6 must be its requirement. It is exposed to external environment. Then what is 7 for water protection? If your motor or battery pack is underwater for some time, okay, then if you take it out, will it still able to operate? If you can give that protection that it will still be able to operate after it was drowned in water for some time, that protection is IP67. Okay, so I'll just give you an example. Yeah, I forgot to include it. Tata Nexon EV, if you get time, you'll see that battery pack is actually on the bottom part of the vehicle, and its bottom part can touch water. So it is totally water linked. It is IP67 protected. So even if you drive your vehicle over water, right, it is not going to get damaged because these protections are given, proper sealed condition. Okay, I'll just spend 5 more minutes on discussing little bit on the battery charger, not going in depth because it is already discussed. So we talked about motor controller unit, battery to motor. Now, how do you charge your battery? Is using a battery charger. So this is an again interesting problem, right? Some of you already asked this question. That's why I am discussing it. Otherwise, I would have skipped that. How long it takes to charge a battery? There are two categories of charger. One is domestic charger, which is basically AC slow charger, which you can use in your home. You can just plug into your regular plug, and that's how you can charge. Another is fast charger. That is commercially available. You go to a charging station that is generally DC. Okay, as it will be a pretty high fast rate charging. So fast charger is a different, it is kind of commercial solution, big players are involved. But let's say if I give you this task, you yourself design a charger for your home. You have a vehicle in your home, you want to design a charger which you can use in your home. What can be the maximum power rating of your charger? Can it be 10 kilowatt? Can it be 1 kilowatt? 100 kilowatt? How much? How do you decide? Right. So I request you to think about it and give me an answer. If you're designing a charger for your home use, domestic use, what can be the maximum power rating of this charger? From that, you will understand why it is slow charger. Any answer? What do you think?
It depends actually the maximum current we are allowing.
You know Indian standard, right?
Yeah, if we take our voltage is always fixed, that is 230 if we take, and we can take maximum current of 15 ampere.
Okay.
So 230 into 15, you can calculate maybe 3.3 kilowatt or something like that.
3.3. Yeah, extremely good answer. Thank you for this. So these things I just noted down here. Two more important point here. 230 volt is our regular voltage. 15 or 16 ampere is the socket rating. You cannot take more current than this, right? And one more important point is power factor. Okay, because power is VI cos phi, right? So these two is known. That's why it is very important that whatever charger you are designing, its power factor has to be as high as possible. Maximum we know it is 1, right? So that's why in battery charger circuit I was showing a unity power factor rectifier. It is not a simple rectifier. If you are using a simple diode based rectifier, your power factor will be very poor, less than 0.8. So then this maximum power rating will get hampered, right? So this into maybe 0.8 or 0.7 depending on your power factor. So maximum rating will even be lower. It is theoretically maximum possible. And one more point, always remember, this is the input power. Maximum input power you can draw. That is not the output power, right? So input power minus loss will be the output power. And when you write down some specification for a product, you always write down specification for the output power, right? When I say 5 kilowatt motor, I mean it can deliver 5 kilowatt of output power, right? It is not the input power. So your input power into efficiency, basically you're taking loss component that can give you the maximum output power you can have. Okay. Now, if I give you the battery spec for Tata Nexon EV, it is 30.2 kilowatt hour. Okay. So you know if I take 3 kilowatt to be on the round up number, so this by 3 kilowatt. So how much I need? 10 hour time. Okay. Of course, you don't need exactly 30 kilowatt is its rating. But as some of you already pointed out, we cannot deep discharge battery, right? So there is a concept called depth of discharge. For lithium-ion battery, it could be 80 to 90%. What it signifies? This 30.2 kilowatt is the available capacity, but it is not fully available for you to utilize. It's 80% may be usable. So what it means? So from 30% if it is fully charged, 100% if it is fully charged, 30 kilowatt hour, till it reaches 20%, maybe it will be having some number you have to calculate. Then you should not allow it further discharge. Deep discharge you should not allow. So similarly, when you are charging back, you have to charge for only around 80%, right? Not 100%. So this number will be less than 10 hours because you don't want to charge, you don't need to charge full 30 kilowatt hour. 80% of that at max you will be charging. So this could be around 9 hours. So this is how you do calculation, and you can understand why it is slow charger, right? Because you need such a large battery pack, and then if you want to charge it at high rate, it is not possible in your domestic use. There's a limitation. Okay. Sometimes battery has a limitation that it should not be charged with very high rate. Okay. So those are the limiting criteria. So here I tried to explain you what is meant by this low power factor and why you should go with high power factor. So this I'll quickly skip through. Yeah. So I talked about motor controller unit. Just give you a brief idea. battery charger limitation I told you. One last point remaining. Yeah, please go ahead.
Sir, in fast charging, it means we are increasing the current rating.
Yeah, what happens is in fast charging is that, see, fast charging, first of all, domestic use, fast charging you cannot use. Fast charging is used where three-phase supplies are available. Okay, there you can have 63 ampere socket, right? And 415 maybe line to line voltage. So you can draw a lot of power. Then what you do is you use an AC to DC converter. So this gets DC, and then you can charge your battery in the vehicle. So this is known as off-board charger. Charger is not there in the vehicle actually. Okay, but for on-board charger, for slow charger, the charger will be there in the vehicle, or you can take it off-board also. But fast charger definitely it has to be off-board. It's a heavy rated system, right?
Okay, sir.
Okay. One more just point regarding power converter, then I'll be done. Is as I told that, see, the battery energy, some part is going to drive the motor, but some part is also need to go for your auxiliary system. What comes under auxiliary system? You have some headlamp, right? Then you have this air conditioning unit, some indicator light, then the power steering wheel, then some display unit, then infotainment system. All those, they need some power supply, right? Everything needs power and energy. And typically they need around 12 to 14 volt supply. Sometimes they need 5 volt also. But the battery you have maybe 320, maybe more than 200, right? For e-rickshaw, it will be 48 volt. So you need a DC-DC converter, right? So there you use an isolated converter. Because as I told earlier, see, the gain requirement is pretty high. Please note that a lot of people has a misconception that boost converter, which we study in power electronics, ideally it can give you infinite gain, right? But practically boost converter gain is limited to around 2.5 to 3 maximum. If you want to have more gain, your efficiency drastically degrades. So boost converter, traditional boost converter, no one uses for a gain more than 2.5. Okay. If you want to achieve higher gain, you should go with isolated converter. Right. So I think my time is more or less up. Next part, what I wanted to show you, I'm not going to discuss that, some of the very interesting vehicle concept. So I'll be sharing you the slide and we can go through it. Some of you are talking about solar car. So here is a question for you. Think about this solar car in Indian context. Let's say you are driving the vehicle only using solar energy, okay? No external charge. How many kilometers you will be able to travel in a day in India? Any idea? Average number.
Maybe, sir, 50 kilometers.
Okay, 50 kilometers. Any other number?
So it may be maximum up to 5 to 10 kilometers, because whatever also less than, maybe we can go less than, because the surface area covered, it will may not be sufficient enough to charge the battery with a full range. Maybe 5% or 6% the battery will charge, and it will be, and that is without any external auxiliary load. Can go maximum 5 to 10 kilometers, because the auxiliary load also, because nowadays what happen, whatever the actual vehicle range the manufacturer claiming, they are without AC only, because when you put the AC, the the range is reducing. But that is the main drawbacks what we are facing, that vehicle is claiming that maybe 200, 300 kilometers, like Tata Nexon, they are claiming around 250 kilometers. And
they are claiming 312.
Yeah, 312, but it is actually it is only 200. 200, that is without AC. 300, 350, that is MG ZS-EV, that is more range around 350, but that is with AC it is around maybe 250, like that. So maybe I think a solar PV, it will not be practical, it is not possible. Maximum within 5 to 10 kilometers we can go.
Thank you for your real insight. Okay. So can you have any other number? Anyone else to come up with some number? We got two answers, right? 50 and 5 to 10. Okay. So the analysis that I did for Indian average condition, and of course without AC, that is around 25 to 30 kilometer. Again, I may be wrong. This is based on Kolkata's average solar irradiance data. If we take it, this see, remember there's a little bit of power generated from sidewalls also. This also on the back side also lightweight panel there. And if you do it for the Toto, right, three-wheeler I showed you, that can give you around 15 kilometer range. There is no AC, of course, as a lightweight vehicle. Okay, so solar can assist you, but it cannot be a a full solution. In fact, if you want to get how do you calculate this number? For example, if I ask you that I want to design a 1 kilowatt solar system for my home, how much area do I need, right? So those calculations are actually very easy, right? But if you give me 10-15 minutes, I can clarify all this. Maybe we can do it some other day. What are the other components you need to build for your home? So all these things are very interesting actually. If you just spend some time, we can discuss some other time. So these are the number that our analysis gave us. Of course, we can be wrong also. Okay, this is some other concept. Due to shortage of time, let me not go into this. Just this 2 minutes I'll take. This is one of the Indian startup. Okay, they developed a self-balancing scooter. I think this video is okay. Maybe you can look into it. This is Ligar Mobility. Okay, you can look at it. What I remember it is IIT Delhi based student startup. Okay, and they developed a self-balancing e-scooter, right? So you won't have any accident driving it. So you can search for it. I already talked about ATAL. They are the leading segment of two-wheeler now in India. Similarly, there are so many other Indian startups. They are doing pretty good job. And someday maybe you can also get interest from this, can inspired from this, and develop your own startup. Maybe you can inspire your students to do some startup, and who knows, maybe someday that will really work out and you can become famous and very successful. So I wish you all the luck that whatever you are doing in your research, in your personal life, everything that goes well. With this, let me wind up. I am not sure whether I could answer your queries or not. I have few more minutes left, so we can continue. Else, if you have any question left or you want to collaborate in some research aspect, please write to me in this email ID. You can note down, or you can go to my website also. And also, please connect to me through LinkedIn because that is required nowadays. And if time permits, do check out my.
Excuse me, sir. One question.
Yeah.
Hello, sir.
Yeah, please go ahead.
Sir, is it possible petrol with electric facility in one that car or bike?
Yeah, why not? Petrol-based hybrid electric vehicles are already there in market.
Means, sir, regular petrol bikes are. Is there any solution to convert to electrical bike?
Yes. For example, if you talk about Hero Activa, right, that scooty. Okay. There is some ready-made conversion kit available. What I will do is maybe you can look for this site, Go one. Just search it in YouTube.
Okay.
So
then,
they
sir,
have ready-made kit.
What the weight of the bike will be heavy or what, sir? If a design modification, etc. Petrol tank is there, then that battery will be fitted to that particular slot.
Right. So actually, if you want to increase the range, your battery size has to go up accordingly, right? So it is a trade-off which you want.
Sir, one more question.
There are 2-3 companies which has a solution.
Okay, sir. Give, sir.
Yeah, please continue.
Sir, what is that battery life, sir?
Yeah, battery life is actually defined in terms of number of cycles.
Number of cycles. Suppose nowadays that
number of years.
Okay, sir. Nowadays I have seen that one bike which is giving, say, if we are going to charge, it is giving 120 kilometers. Okay, 120 kilometers. Then what is the battery life, sir?
Right. So let me clarify what I understand from this perspective. First, let us understand what is number of cycles. Okay.
Okay.
Once you are fully charging the battery and fully discharging it, that is one cycle.
Okay, sir.
Okay. Now let's say, for example, this Tata Nexon EV, if we take an example.
Okay, sir.
As some of you already told that its range will be around 250 to 300. Let us say 300, just for sake of argument. So you are charging your vehicle once it is fully charged, and to discharge it fully, you may need at least 1 week or so, right? Depending on your driving pattern.
Okay.
Right. So lifetime would be maybe 8,000, 10,000 cycles. So you multiply with number of days you drive, and that's how you get battery life.
Okay. Okay, sir. Thank you.
Okay. Yeah, so I would also request that if time permits, you check my YouTube channel and let me know what kind of topic interests you, so that I can slowly start uploading some lecture which may be of your interest. And so this some laboratory experiment based demonstration I've already uploaded, and some electric vehicle related topic also I am planning to upload. But if you have any suggestion for me that, sir, I can take up this topic and that, so maybe that will help me.
Hello.
Sir, one more
So
question.
let me wind up. Thank you. It is already 12:30. Thank you.
Okay.
Yeah.
Sir, one more question. Hello, sir.
Yeah.
Hello, sir. One more question.
Please go ahead.
Hello, sir. Sir, suppose if present petrol bike plus that
please go
is
ahead.
EV bike. Okay. Is there any government giving concession, sir, discount regarding what that solar we are going to taking for our home now? They are giving concession, government.
I think I did not get your question clearly.
Yeah, that subsidy is declared in different states in different manner. Like in Gujarat EV policy 2021, they have declared subsidy.
Okay, sir. Okay.
So I think all questions sir has cleared very nicely.
Okay.
And thank you very much, sir, for your
Thank you,
nice
sir.
lecture.
Thank you.
Very informative lecture.
Okay.
I would like to call Dhaval, sir. You can now go for the next session, please. Thank you very much, sir. Thank you very much, sir. Again, sir.
Thank you. Yeah, all the best.
Okay. So for the next session, we will continue on the same link. Okay. So for the next session, I introduce Professor Sudhir Gupte, sir. Dr. Sudhir Gupte is a professor of automobile engineering and aluminum ADIT. He was HOD automobile engineering from January 2007 to September 2019 at ADIT. He joined academic after serving for 28 years in a design, development and service department of various automotive industry like Premium Automobile, Hindustan Motors, Tata dealership, etc. His bachelor degree in mechanical engineering is from the MS University. He did ME in a machine design from VJTI Mumbai University and completed doctorate research on hybrid electrical vehicle from SP University. Dr. Gupte worked on 4 industry-sponsored consultancy projects at ADIT. He has a delivered expert lecture in most of the reputed institute and university in India, including the SRM, LDC, BVM, EREI. He has shared platform as one of the panel member on CII and international conference at Mumbai, Chennai, Delhi, Ahmedabad, and Pune. Dr. Gupte was coordinator for the automobile engineering at GTU SPU. He is an active academic counseling member at VIT ARI Academic and the VETTEC EREI Academic for UG, PG and PhD. So I welcome you, Sudhir Gupte sir. So now I hand over this session to Dr. Gupte sir. Sir, your mic is muted. You just unmute mic, sir. Your mic is muted.
Thank you, Dhaval, Professor Dhaval, for a nice introduction. Let me share my PPT first and then begin. You've given me the rights for sharing the screen share.
Hello, sir, any issue?
Have you given me the rights to
Yes.
share my screen?
1 minute, sir. I think I have already give. 1 minute, sir. I will check again. Yes, sir. Now you can share your PPT, sir.
સરસ કરે પાછળનું ગ્લેર બ્લર એવું કેમ નું એટલે ઓપ્શન જ આપો.
Chudasama, sir, please mute your mic, sir. Gupte, sir?
Can you see my screen?
No, sir.
Now?
Still not.
Just a minute. Should I share the entire screen or window? What is that?
Still, your screen is not, sir.
Okay, okay. So let me cancel this first. Please allow me to share again.
Sir, I have given you the command for same, sir. So now you can share your screen, sir.
Is that okay now? Entire screen or window? What should I select?
Sir, entire screen.
Okay.
And then share. You just press the share button. After that, but yes, sir. Now your screen is shared.
Is that okay now?
Yes, sir.
5.
I request all the participants.
Good afternoon, everybody. Professor Dhaval?
Yes, sir.
I'll be changing my mic now, and in case there is a problem, just call me, okay?
Yes, sir. Okay. I request all the participants, please make sure you have to mute your mic, okay? So unnecessary voice is not entered into the presentation. So it may disturb the other participant also. So please
Good
make
afternoon,
sure
everybody. Thanks to Dr. Kalpesh Chudasama, Professor Dhaval, Dr. Hardik Shah, and other co-coordinators for inviting me for this FDP. My introduction, I would thank Professor Dhaval for a nice introduction, and I will begin with the slide. If you take care of nature, nature will take care of you. This is what was said by David Attenborough, the environment expert. And my topic of presentation today is EV-HEV potential, electric vehicles, hybrid electric vehicles potential and avenues for future. In this, I would have an overview of automobile markets, past, present, as well as EV-HEV, recent automotive movements, automotive industry movements, what is in store for future, and then setting the course for 2030. As a part of case study, I would cover my research project on conversion of existing diesel engine car converted into hybrid electric car, thereby challenges for EV. I think these challenges everybody would be discussing, but my perspective will be from the point of view of an automobile engineer or mechanical engineer, which probably may be of your interest, and that will give you a lot of insight as to a lot of like research avenues for all the professors from electrical electronics engineering who are participating today. And I was requested for additional point to be discussed with the perspective of vehicle dynamics consideration for vehicle design. So I think this will be a good session for you to go on with different perspectives from an automobile engineer with an experience from automobile industry as well as academia. To begin with, the past trends from 1994-95 data. Those days it was being compiled as the number of vehicles manufactured by the industry. All industries put together. There is a society called Society of Automotive Engineers, Automobile Manufacturers Association of India, SIAM, which used to gather all the information from the industry, and thereby they used to publish the data of manufactured vehicles in the country in the financial year 94-95 onwards. Those days, sales data was not available. Rather, the industry was not sharing. So, if you begin with 1994-95, the total vehicle sales manufactured were 2,64,000, which in 2000, the first kind of rise, the big rise which was observed was 574 after opening up of economy, and the economy was growing. The vehicle manufactured by the automotive industry was growing. The automobile industry was booming all across throughout the year up to 2007-2008, where the global recession was hit, and thereby the vehicles sold in 2008-9 went back to 15,16,000, the same as the previous year. Of course, it did not go down, but next year, 2009-10, it went up again to 19 lakhs, a good rise again, due to strong domestic demand. Whenever the recession has hit global world, India was affected, but however, the effect of the recession globally was marginally affected India, because the domestic demand in India, because of the population in India, is so high that the impact is not very much. Again, if you see this from 2010 onwards, the data on sales was published by SIAM. So that is what I am showing you, because 2010 onwards, the sales data shows that 25 lakh cars and total 1 crore 54 lakh vehicles were sold in the country, and that went up to 2012-13, and again, because of fuel prices, global economic impact, as well as, if you remember, 13-14, the government scams were being in the news, as well as a lot of political activities and uncertainties were being observed those days. That is why there's another recession sort of effect was experienced in automotive industry, and the vehicle sales, the passenger car sales went down to 2010-11 level. But however, due to the two-wheeler sales, four-wheeler sales went down to 2010-11 level, but two-wheeler sales had increased, and thereby total vehicle sales was again higher than the previous year. That is 1 crore 84 lakhs as against previous year 1 crore 77 lakhs. But again, the same picked up in 2014-15. If we go by next 15-16, 16-17, 17-18, as well as 18-19, the sales was rising year by year, and progressively the automotive industry has been doing very well. But again, 2019-20, the fuel prices, the China crisis at Galwan, then Bharat 6, there was a dilemma. People were not able to decide as to what should we do about EV, whether they are going to be surely coming or not. And then the sales went down because of various other reasons as well. And the total vehicles sold were 21,546,000 vis-a-vis previous year 26,266,000. If you look at the data of passenger cars, it went down to 15-16 level, year 2015-16, whereas for commercial vehicles 16-17 and three-wheelers, two-wheelers again 16-17 or 17-18 level. But overall, the total vehicle sales from in 2019-20 went down up to 2016-17 level. So we have gone back to 3 years down the line. However, again in 2020-21, we have same thing, COVID lockdown, uncertainty of economic development, waiting for industry, waiting for revival. The entire human race, the human community has been waiting for revival. That's why the volume again went down and went to 18,615,000, and we have gone down to 2013-2014 level. So last year we went down up to 2016-17 level number of vehicle sales, whereas in 2021 we have gone down to 2013-2014 level. It means we have gone back to Congress era again. But there's a good sign. There's a recovery in the first quarter of financial year 21-22. You look at every company, they in the marketing they always look at the number of vehicle sales in the same period previous year. That is why you can see Maruti Suzuki from 64,000 it has gone to 2,93,000. From Tata Motors 14,000 to 64,000. Hyundai 28 to 1,14,000. Honda similarly gone double, triple. Kia has sold as against about 9,000 to 42,000, and Mahindra from 11,000, 12,000 to 43,000. Similarly, all these car manufacturers, this is the news about a week back in Divya Bhaskar. So, if you see globally, initially hybrid electric vehicles seemed unnecessary for the people due to low cost of gasoline and very high cost of the hybrid electric vehicles, the initial cost of the purchase of the vehicle. But later, due to concerns out of national oil security world over, the same scenario was observed. The national oil security and better fuel economy, reduction in harmful gases emissions, it gained importance from 2000. We will see the data as to how the changes have taken place in the number of vehicles sold world over in this kind of scenario. And it is perceived as, now it is being perceived as a core segment of future automotive market, electric vehicles and hybrid electric vehicles. Worldwide total 17 million hybrid electric vehicles were sold by April 2020. US, it was 5.4 million from 1999 to December 2019. Europe, it was 3 million cars from 2000 to 2020. And Japan, it was 7.5 million from up to March 2018. And just note, it was 19% of the market share for new cars. New cars registered or sold in the Japanese market. 19% market share so far, none of the countries have achieved. If you look at the market EV, HEV statistics for passenger electric vehicles in European Union, I think our Dr. Sudani also mentioned about this, and Dr. Vishal Singh also mentioned about this, that European Union has earlier decided with the global commitment that they will stop or rather ban petrol diesel vehicles from 2040. Instead, they have recently announced in February that they will ban petrol and diesel vehicles from 2030 onwards. It means all the vehicles that will be sold in from 2030 onwards will be all only electric or electric hybrid vehicles. So if that is the case, just see what was the scenario in 2015. It was only 0.4 to 0.4% for electric vehicles, and plug-in hybrid vehicles were 0.6% of the vehicles sold in that year. Total vehicles sold in that year, and just 0.4, which has gone up to 5.3% to 5.3% for electric vehicles, and plug-in hybrid vehicles 5.2% in 2020. This is just meager figure by 2020, and just imagine by 2030 they are going to sell 2030 onwards they are going to sell all 100% electric and hybrid electric vehicles. Despite the pandemic, again the good news, despite the pandemic causing global automotive industry to shrink, the global automotive industry has shrunk by 16%. But however, electric vehicle sales posted a strong growth during this crisis. Record 3 million electric cars were registered globally last year. That is 2019. That is 41%. That is 41% higher than. This 3 million electric cars were sold in 2020, which was 41% higher than 2019, and that trend has continued in 2021 as well. During the same period, 2020 last year to 21 this year, it is 2.5 times as many registrations recorded during the same period last year. So it is the last year 2020 total globally 11.3 million electric hybrid or PHEV fuel cell cars were sold, but projection is 51.7 million in 2025 and 114.3 million by 2030. So you can imagine what is going to be the potential for electric vehicles world over. If you look at this data, which is for 2020, total 27,260 electric two-wheelers were sold in India. Okay, out of which there were about 29-30 manufacturers in 2020 who had sold vehicles, out of which only 15 manufacturers had actually sold more than 30 vehicles. Okay, and the information is about 27,260 vehicles were sold in 2020. Globally, the new energy vehicles, they call it new energy vehicles, that is electric vehicles, some hybrid vehicles. Generally, this full hybrid electric vehicles and micro or mild hybrid electric vehicles, they are considered as IC engine vehicles, and that is why this data is separately plotted. Otherwise, battery electric vehicles 27% and plug-in hybrid electric vehicles 12% is what is recorded globally. And number of electric vehicle cars models into region wise, if you look at, that was total number of models that were seen last year 2020, that is 138 number of models were seen in China, about 60 models in Europe, 17 models in USA, and India there were only 4 vehicle manufacturer models are available for EV vehicles. Over 8.3 million new energy. This is again a different data, but however, similar to 7.8 that million I talked about in the previous slide. Globally, 2009 to 2020, total 3.2 million electric vehicles sold by 2020. It means 40% growth in sales vis-a-vis 14% decline in overall global automobile industry. That's what I talked about from some different data from different researchers. So if we look at the monthly sales for India, it had gone up to 16,435 in the month of January, which dropped to just 901 for various reasons in this country. Like beginning of COVID is one reason, China Galvan crisis, China is another. But however, most of the electric vehicles sold in India are those which are registered as three-wheelers, and the battery used by those three-wheelers is lead acid battery. So there is a major kind of setback, as the user always has faced some or the other difficulties for using those lead acid batteries and not using the long life high energy density lithium ion or such other battery compositions. But however, from May 20 onwards, again it has gone up to February, March 21, and as expected in April for COVID second phase, it has gone down. If you look at the state-wise distribution, Uttar Pradesh has sold about 22%, 14% Tamil Nadu, Karnataka 13%, Rajasthan and Maharashtra about 7-8, and rest of the country, rest of the states like Kerala, Assam, Bihar 4 to 5%. Where is Gujarat? We are among this 15% total. Other states 15%. Gujarat, we need to do well. But now the good sign is government of India, government of Gujarat, government of Maharashtra, Delhi, all the state governments have announced their own EV policies. EV sales in India has been 0.64 million from 2012 to 2021. Okay, and if you look at this sudden rise that was in 2016, where actual awareness of electric vehicles and government push started, and thereby from nowhere, that is every year from 2012 onwards, there was a degrowth of electric vehicles because of the vehicle configuration, whatever kind of quality of product that was sold that time, the degrowth was there every year. Whereas from there on, 2015 onwards, 2016, we had a very good jump up to 647%. That is a very high number percentage wise, but the numbers in absolute numbers, it was just 20,000 vehicles sold in a year. Whereas we saw there were 18 million vehicles sold in country. So still, however, the vehicle growth of electric vehicles and hybrid electric vehicles went on up to 2020 and 2021. Again, there is a degrowth, but that all is known to everybody about this COVID-19 effect. Now, if you look at this distribution of vehicle-wise vehicle cells, EV cells, then electric two-wheeler is 31%, where out of the 64%, 64.64 million, that is 6 lakh 40,000 vehicles sold till 2021, electric vehicles. 31% is two-wheelers, 66% is three-wheelers, and only 3% is four-wheelers. We are not talking about electric buses so far. And also, let me tell you this, 66% three-wheelers are those vehicles which are started registration a few years back after the government regulation came into picture. So, it is actually two-wheelers and three-wheelers is about 96% of total EV sales in India. And e-rickshaws, low-powered two-wheelers are not part of this because they are exempted from registration. So, from after COVID now, the industries have started improving the production ramp up. And please note that there were some about 8-10 new models launches in April 21, and there are 4-5 more coming up in the next year. So, if you look at the recent advances and trending words that are being used in mobility industry, which were not there part of the mobility industry about 5 years back, because they were all IC engine vehicles, and this kind of words were not even heard of in automotive industry. High energy density batteries and BMS and life cycle, then battery chemistry for battery technology, updated technology, then fast charging, supercharging, contactless charging, EV charging infrastructure, EV, HEV, hydrogen fuel cell vehicles. The standard for fuel cell vehicles is now ready. Then people are talking about mass and low cost mobility. This is yet to penetrate. Our buses are not yet getting popular, but government of Gujarat has started, as well as many other states have started buying electric buses. The mass mobility, so long as the mass mobility penetration is improving, the electric vehicle impact will not be there in the minds of consumer. Now, consumer sentiments are there for the electric vehicles. Then government policy regulations, OEM strategy, and all such things are being talked about now. Reduction in greenhouse gases, net zero emission, environment friendly renewable sources of energy, air powered bike, ethanol powered electronic vehicles. With all this, actually speaking, when we talk about EV, petrol diesel price rises again is the major news nowadays. Value has introduced 2 to 3 wheelers powertrain, which is going to make a lot of difference in cost effective electrification of small mobility vehicles. There are a lot of startups making India e-bikes. As I said earlier, the Britain, UK to ban sales of new petrol and diesel cars from 2030. So by 2030, they will be ready for only electric vehicles. So what is in store for future? The store for the IC engine is going to get replaced by EV, HEV, e-mobility. That is what the technological disruptions are going to take place. That is what is the future now. And with this EV, HEV, autonomous vehicles, ADAS, auto driver assist system, infotainment, IoT, artificial intelligence, LiDAR, blockchain technology, cloud computing, edge computing, and all these major actions related to environment, safety, and comfort are going to take place with EV, HEV more easily and cost effectively as against IC. So I say the EV time is now. Actually, environment and public health concern have been predominantly the main motivation for electrification of on-road vehicles, but even the off-road vehicles are also joining. The driving force for electrification of vehicles is increasingly the economic purpose. For end user, it is per kilometer running expenses. For government, cost of crude oil import. which amounts to national social security, and the root cause is depletion of fossil fuel. If this fossil fuel is not there, what are you going to do with those vehicles? So actually the EV is demonstrating its green credentials. Also, it is likely to save money to their customers. Hence, there is a huge business. Like if you are aware, Amazon, Flipkart, Swiggy, Zomato, all these delivery vehicles are slowly converting into EV, and these companies are actually now leveraging their collective demand through corporate electrical vehicle alliance. And I heard even Ola is getting into electric vehicle business. Government policymakers are pushing to accelerate the transition of commercial vehicles, buses to electric. Hence, increasingly wide range of EVs are becoming available. All major OEMs are entering into EV, otherwise the market share will go down. Government is supporting the EV industry, realizing strong mass production of EV across all categories. Government has offered compelling financial incentives to make electric switch to achieve target of 30% of market share by 2030. So electric vehicles setting course in the 2030. Currently at 2019 figures, we are the global scenario is 2.5% market share of total vehicles sold is EV or HEV. But by 2030, it is expected to reach about 30%. That is the target set world over by all the countries. I mentioned earlier that Japan was at 19% already by 2018, and by 2020 Europe was only 5.2 to 5.4%, whereas their government, the target world over is 30% market share from ICE to electric or hybrid electric vehicles. If you look at regionally, US is India is nowhere, but US is also the lowest in this graph. Then Europe is marching ahead, and China is way ahead. And by 2030, as again, it is expected to be the global expectation is about 30% of electric vehicles as against the total vehicles sold. This is the graph for hybrid electric vehicles sold in United States by 2019. It had gone up to 3.19% by 2013, but then again 2019 it has come down to 2.4. So what are the consumer sentiments? Why EV adoption is so difficult? The concerns regarding battery powered and EV vehicles and hybrid electric vehicles are mainly driving range anxiety, maximum speed, which was low earlier, and that is where actually the electric vehicles got the setback. That earlier many vehicle manufacturers, two-wheeler or three-wheeler manufacturers, they had low powered and lead acid batteries provided along with those vehicles, with the cost of the vehicle being high. People thought that the electric vehicles cannot achieve higher speeds, and that is where actually the setback had started. But the same scenario is not there today. You can achieve the max speed available because by virtue of technology and the drivetrain design. Then the running cost versus initial price premium. This is still the concern which probably will get offset by end of my presentation. I think I will show you that how the vehicle cost of initial cost of the vehicle will go down with respect to IC engine vehicles. Now, time required to charge is another concern. Lack of electric charging infrastructure, which is also being built. Safety concern with battery technology is there. then fear of load on grid if 100% transition. Well, this is the government lookout, but government is already setting up renewable energy sources in large capacities. Like in Bhuj, they have set up a huge capacity of solar and hybrid electric producing renewable energy producing field, which is going to offset this additional requirement of the power. Daily charging inconvenience. Consumer demands exactly a comparable to ICE. That is, if we go for a fueling, it takes about 5 minutes to fuel the tank. The similar convenience they are expecting from EV as well. And onboard charging system. These are all concerns or sentiments of consumers. Driving factors are basically government incentive. Government is driving it very hard. 30% market share in 2030. Climate change is something like government of India has committed to Paris Agreement to cut greenhouse gases emission by 33% to 35% by 2030. And energy security, this is a major problem or concern for the government. The oil import is about 82%, and we have committed to generate 40% of energy through renewable sources. And rapid urbanization, actually, if you look at world over, out of 20, about 40 most polluted cities are in India. The same thing that the total vehicle electrification, the global share, they're talking about the buses has to go up, but as they say, by 2040, 77% of buses, 65% of two-wheelers, 85% of three-wheelers, and 40% of passenger vehicles are projected to be electrified. And the same 2040 electric two-wheeler share will reach almost 77% out of total two-wheeler sales. So just wait for 10 more years. 2040, by 2040, almost 27% of the vehicles, two-wheelers sold will be electric vis-a-vis total vehicles sold. To substantiate this growth in electric vehicles as well as automotive industry, the government had a vision and targets as per Automotive Mission Plan 2026. The vision said 3, 12 and 65. What is this 3, 12? 3 is by 2026 Indian automotive industry will be top 3 in the world in engineering manufacturing, for export of vehicles, automotive components, and will encompass safe, efficient, environment-friendly conditions for affordable mobility of people and transportation of goods comparable with global standards. Now, this they say will be growing in value to over 12% of India's GDP, and it will create 65% 65 million jobs in our country. How this will happen is through Make in India, Skill India, and Atmanirbhar Bharat. Furthermore, if we see, it is expected, the target says that Indian automobile industry will grow 3.5 to 4 times from 2015 to 2026, which means that 2015, the total automotive industry rested at 4,64,000 crores, which is likely to be 16,16,000 crores to 18,89,500 crores by 2026. That is what is Automotive Mission Plus. That is actually for 3.5%, 3.5 times to 4 times. This is what it shows, that OEM domestic sales is likely to go from 292,000 crores to 9,32,000, and OEM exports, OEM components, and OEM component aftermarket. So all put together from year 2015 to 2026 as the base case, that is going to be what you can say conservative or target. It is going to be 3.5 times, or otherwise up to optimistic, if we all goes well, it is about to reach 89,000 crores. So this is what all about potential. So there is a huge potential for electric vehicles in automotive industry, and rest assured, all these professors from electrical electronics, you will have very nice opportunity if you are continuing with your research and like study on electric vehicle components and details of vehicle components required for automobile industry. So the previous speaker must have talked about the types of electric vehicles, hybrid electric vehicles. I'll just briefly go through. ICE and electric motor both are connected in parallel, and ICE motor power are equivalent. ICE, that is IC engine, and motor power are equivalent in parallel electric hybrid. And series hybrid, the ICE engine is smaller engine. They have larger battery pack than parallel hybrid electric vehicle, but the ICE is operating at a low emission, improved economy, and the electric motor drives the vehicle. Combined or split hybrid, both are connected to transmission and differential. Then fuel cell vehicle, but there are some plus as well. What I have to explain to you is that plug-in hybrid and then full hybrid electric vehicles which has onboard charging and in-wheel motors. HEV of course HEV can be used in different modes, but generally I would point out to you that short distance daily usage of not more than 50 kilometers, the plug-in hybrids are all very popular. But the EV or HEV user do not want to go to the gas station regularly. That is why these plug-in hybrids will become popular. So some of the types of hybrid, micro hybrid, mild hybrid, full hybrid, and plug-in hybrid, the start-stop system, yes or no, I have given a chart to briefly understand. So I'll come to, I don't know, I am running slow or fast, but let me come back to the point that case study about my PhD project. This was on reduction in consumption of fuel in existing diesel cars. The causes for growing concern have been discussed several times in several webinars earlier, so I will not talk about it, but particularly national oil security is a major concern for switching over to electric vehicles. But the rise in volume year on year of cells adds to the gravity of problem. For same depleting fossil fuel or national oil security, till the time 100% EV switching is not taking place, year on year, huge number of IC engine vehicles are being sold, which are adding to the gravity of problem. And replacement of vehicles on road to non-polluting EV is just unattainable. It is necessary to have proper solution to convert existing vehicles into EV hybrid electric vehicles. That was the preamble for my project in AV. You all know advantages and disadvantages of EV, HEV, but the government of India's actions towards building infrastructure for EV will nullify those disadvantages. And this was one statement which was inspired me to go on for a project on EV. Important social and economic benefit would result by implementation of EV and HEV. So my objective was reduction in consumption of fuel in existing diesel car by retrofitment of 2 DC hub motors directly on rear wheels. This was conducted on my own personal vehicle in Automobile Engineering Department of ADIT. The vehicle is still available with AD Patel Institute of Technology. All of you are invited to come and see that vehicle, still in working condition. And this was a front engine, front wheel drive vehicle with semi-trailing ring suspension. While the research is oriented towards conversion of existing vehicle, it can be implemented widely in the currently manufactured vehicles or new models that can be introduced by automobile manufacturers. Excuse me. This concept, if appreciated and adopted by the existing car manufacturers, a huge production of cars can add value to the corporate social responsibility and able to compete in the automotive world by reduction in per capita fuel consumption. This is very important for the knowledge of all the participants. Per capita fuel consumption in our country is probably the least as compared to anywhere else in the world, and US is the highest, and hence the drive for electrification is coming from this western world to all those Asian countries. Concerns related to low and high speed operating conditions for enhancing range and improving the fuel consumption. Now I would say that IC engine vehicles, when operated for maximum acceleration and cruising while driving at high speed, the engine demands more gasoline, right? Gasoline or diesel at high engine RPM. When you're driving on a highway with a high speed, obviously the high speed can be achieved by additional supply of fuel. Thus, the consumption of fuel is very high on highways at high speeds. At the same time, similarly, electric motor draws maximum current at low RPM. So, when you're starting from the zero speed, standstill condition, in stop and go condition, the current drawn from the battery for picking up the speed at initial stage is very high, because the torque demand is high, the current consumption is high, and that is where the battery storage will get depleted very fast if the electric vehicle is used in electric mode. Hybrid electric vehicle is used in electric mode under stop and go condition in electric mode. So under both these above conditions, one at high speed on highway and for IC engine, and electric motor, electric mode in stop and go condition, both the conditions, it's a losing proposition regarding any energy utilization, and end results is the limitation of range. The range will reduce for electric vehicle and low fuel average for, and as well as high pollution for IC engine vehicle. For highways and for stop and go city driving conditions for electric vehicles, both are losing proposition. So I have proposed method. Proposed method falls in the purview of draft AIS 123, which is for retrofitment of electric vehicle, electric kit on the existing vehicle. to make it hybrid electric vehicle system. So this prototype actually about 50 to 60 kg extra weight was added in the curve weight, which was only within 5% of the curve weight. Here the engine remaining same. The engine and driveline, which was front engine, front wheel drive, it remained the same. So specified gradability, acceleration was retained as a normal mode, normal vehicle, conventional vehicle, which was already certified by regulating body. And during the period when electric motors are driving the vehicle, the IC engine for front engine front wheel drive will be running at an idling speed to run those power steering, then AC compressor, water pump, radiator fan and alternator, because these are the items which will be required for running the vehicle, and that is why to operate this power steering motor pump and all the power steering pump and compressor and all AC compressor and water pump, we need engine to be running at idling. That is the reason why the fuel average will have an impact. But however, for an existing vehicle without electrification, without a hybrid electric vehicle, the consumption of fuel will be much higher as compared to when it is converted into hybrid electric vehicle and running in electric mode on highways. That I will explain. Now, two hub motors are directly coupled to non-driving rear wheels. As I said, this vehicle was hybrid front engine front wheel drive vehicle, and the rear wheels were non-driven vehicles, non-driven wheels, and in those wheels I had fitted the hub motors. So the block diagram is here. The front, this is the front of the vehicle. Now front RH tire, LH tire, rear LH and rear RH tire, the permanent magnet BLDC hub motor 1 and 2. There are two controllers in the dicky. There is a battery package kept in the dicky, and accelerator pedal for the IC engine as well as for electric motor, and then IC engine front engine front wheel drive is shown here, which is which is driving the front engine front wheel drive. So when the engine is running on idling, the gears are not engaged and the wheels are free to rotate with the power provided from the hub motors in the rear wheels when the vehicle is moving in the electric mode. When the vehicle is moving in the IC engine mode, these wheels are free to rotate and electric power consumption is marginal, minimal. So the testing methods and routes that I have shown here is the vehicle to be converted was tested in as is condition without converting into hybrid electric vehicles for different routes with the same load, tire inflation pressure, same driver, etc. And then the vehicle under similar conditions were tested after conversion into electric mode, and then the same vehicle was duly converted as hybrid electric vehicle for in IC engine mode again. So it was tested as it is without converting, then it was tested with hybrid electric conversion, because the additional weight I wanted to check. With the additional weight, the fuel consumption for IC engine mode vehicle, if the battery runs down and if you have to run the vehicle for a longer distance, it should not be very heavy on the IC engine fuel consumption. So that test was also conducted, and the tests were conducted with hybrid electric vehicle in EV mode, where engine was running on idling for those accessories to be powered by the IC engine under idling RPM. The routes were considered as a state highway from Vidyanagar to Tarapur, Vidyanagar to Dakor, and expressway number 1, then stop and go city traffic and Anand Vidyanagar, Vadodara. See, these are the pictures where I have fitted this hub motor inside the suspension arm suspension arm and the suspension shock absorber remaining same. I had removed the axle. I had fitted the hub motor, a disc brake. Instead of brake drum here, we have fitted disc brake and the motor and the tire. Now this one was the first phase. I will show you next. This is the first phase where if you see the available existing motor with the maximum kilowatt motor available in hub motor those days in the year 2008 was only 2.5 kilowatt, and that is where the available motors were modified for the shaft and the brake disc, as well as the end disc, inner and outer, and then the fitted the this tires, where if you see the tires had gone out of the vehicle about 220 mm. So then subsequently we developed another motors with the bigger diameter of the motor, so that the stack height of the motor will reduce, and still however about 20 millimeters offset. The wheels overall width was higher, which again was due to the some of the outer and inner motor end disc were thicker, which can be accommodated in the further development. This is the picture of batteries placed in the dicky. The stepney is removed. However, this was being tested as a prototype, so this one was this arrangement was made. Otherwise, special arrangement for stepney can be made. Fuel tank can be made smaller. So this kind of changes can be provided. And these are the controllers, two controllers fitted on the fixed on the rear bumper inner panel. As I said, about 220 millimeters rear wheel track increase when the first attempt, and then subsequently we developed another motor with bigger diameter and the stack height reduced drastically, and we were able to accommodate the wheel completely inside. The wheel track was almost the same. So this was the inner disc and outer disc designed and manufactured for the requirement of the brake disc for the inner plate and for the fitment of the wheel for the outer this thing. Apart from this, there was another issue that we had understood, that the motor design and motor application, for the purpose that we had selected, we thought that the bearing size will have to be different, and we had used two different bigger size bearings. That's why the entire shaft design. See, this is the brake drum which was existing vehicle, which was removed, and we had replaced it with hub motor brake disc, brake drum to brake disc, and the drive shaft, axle shaft has got hub motor on that with a disc brake here. So this is one fitted already, and later on the vehicle is on the wheels with the motors inside. So this conversion kit was comprising of permanent magnet BLDC hub motors 2, controller 2, motor accelerator pedal 1, and battery pack. We have an option of choosing from battery, lead acid, lithium ion, lithium polymer, or air aluminum, or maybe sodium vapor, which the choice should be actually what you can say, the high energy density battery pack. This system, permanent magnet BLDC hub motor system, was 48 volt system. We had chosen 48 volt system. That time it was only 2.5 kilowatt highest capacity, I mean highest power motor was available with 48 volt system. Otherwise, for better performance, we can go up to maybe 60 or 72 volt system. The wiring harness, then 48-volt plug-in charging system, disc brake system for rear wheels, and measuring instruments. It was only the stator and rotor were kept the same from the motor that we developed, which is available from the ready manufacturer. Otherwise, this brake disc was newly introduced by us as against a hub drum braking system. Then this, to accommodate this disc brake, we had to design and develop this uh, outer plate of the hub motor. Then this bearing was replaced, since we were manufacturing the same shaft that was available with the motor would not have been useful for us. We had to dismantle the entire hub motor, and then we had to develop a new shaft, wherein this shaft we changed the bearing outer and inner bearing we had used, which was self-aligning double ball bearing, because this was important because the vehicle will have a differential function, that is longitudinal forces and lateral forces acting on the rear wheels when this vehicle is being driven by the rear wheel drive motors. So this double ball bearing, self-aligning ball bearing was very important, which was not part of the motor. So accordingly, this shaft was designed to accommodate the stator, then the newly designed outer disc, then inner disc, this bearing, and then a retainer was also developed, and then the shaft to accommodate all this, so that there is a tightening nut, which axle nut can be tightened here. So if you look at the next slide, this is the shaft which was designed and developed. The vehicle was tested rigorously for hundreds of kilometers with EV, without EV, or rather conventional mode, but still the vehicle is in intact condition, available after 4 or 5 years till today. This is the retainer so that the bearing doesn't come out. The process of conversion that I had rather put down, how we did that. Motor outer and inner covers were dismantled. Then stator shaft. This being hub motor, the outer body of the vehicle motor was rotating and the shaft was stationary, unlike conventional motor. So the motor outer and inner covers were removed. The stator shaft with stator winding was removed from the housing rotor. Then motor stator shaft with inner and outer bearings was removed. And design and manufacturing of outer cover motor to suit the standard wheel rim of the vehicle, and inner cover of motor to adopt the brake disc was designed. The shaft suitable for mounting in the suspension arm. The motor available to us was not accommodating the suspension arm. So accordingly, we had to take care of the suspension arm on which this shaft was mounted along with the motor, and it was accommodating the bearing. This was changed from whatever bearing was provided by the manufacturer, and double ball self-aligning bearing for the outer cover. So while putting it on the vehicle, this was the previous one was the disassembly and assembly of the vehicle, modification and improvement for accommodating the motor onto the vehicle, and this one was the assembly of motor with the shaft fitment on the vehicle. The process is explained here. So assembly of BLDC on suspension arm, how it was done: disassemble the removal disassemble the axle from the vehicle, that is by removing the wheel rim first and wheel rim and tire assembly, disconnect hydraulic brake pipes for rear brakes and remove brake drum assembly, dismantle lower mounting bolt of the rear shock absorber and two lower arm fixing front bolts for dismantling the suspension lower arm. Remove the axle shaft from the lower arm by using 15-ton capacity hydraulic press and the assembly was done by assembling the suspension arm assembly with BLDC motor on the vehicle by fixing the front end mounting bolt, then fix shock absorber lower mounting bolt. So it was a matter of once that assembly was readily available, motor assembled onto the axle shaft, it was with the suspension arm, it was a matter of only 2 hours or 2 to 3 hours to fix that motor assembly on with the suspension arm onto the vehicle. And then bleeding of the brakes. So how did the specification, vehicle specification stand for when this vehicle was hybrid electric vehicle? So the engine peak power remaining same, engine maximum torque remaining same, the peak power of motor which was total 2.5 plus 2.55 kilowatt, and a hybrid electric vehicle pack 150 ampere hour battery that we had used, lead acid conventional, which is very high weight. Passenger weight was 150 kg, same to same for testing. Curb weight of the IC engine vehicle was 1050, whereas it went up to 1250 with the hybrid electric vehicle. So it is almost about 200 kg extra weight because of the battery and electric vehicle kit. Also that we had tested this the phase 1 motors which were not usable on the vehicle because of the increasing the wheel track. What we did was we tested these batteries on the test bed to find out as to how does it perform, particularly no load condition, and the test figures were like we were able to test it at different RPM. We measured the RPM, we measured the current, and we saw the duration as to how much duration that this battery will last, and thereby we can estimate as to approximately how many kilometers or for how long can we run this vehicle on road. So major factors that affect the fuel efficiency, fuel consumption, were not vehicle related, but it was other things than vehicle related or driveline related, which vary according to load, according to engine, some tampering with the engine induction or fuel system. So all those things were kept intact by us, so that before being converted as IC engine to EV, HEV, or after conversion of HEV, these parameters will not have any impact on the fuel average measured by us on the all three conditions. So that is why engine, load, drivetrain ratios, body type, aerodynamic drag forces, tire properties, everything was kept same. Even the driver was also kept same, and the routes were also same. On the same route, 3 routes or 4 routes, we had driven by the same driver and same co-driver for assisting the taking down the measurement of fuel average was continued for the entire complete test. And I would here like to mention and thank Mr. Patel of Automobile Engineering Department of ADIT for assisting me for all this testing throughout the year, maybe more than 2 years actually. And I would like to express my gratitude to him. So testing, why EV drive change, as I said, that prior drive cycle change, because Prius changes EV during congested traffic condition. Toyota Prius I had seen myself in US, which changes from IC engine mode to EV mode in congested traffic condition and runs on IC engine on highways for high speed. Those days I am talking about maybe 2007, 8, 9, and for it is okay for urban driving cycle in metro cities, but in other cities, car users are driving in cities for 10% of distances and remaining on highways. For in India, for example, we generally, those car users, 10% of the times they are using in cities and the rest of the time it is on highways. For high speed running on highways, obviously fuel consumption will be high, and with low powered light vehicle, lightweight BLDC hub motor, it is proposed to run on IC engine in city traffic and switching on to EV on highways. So with the kind of testing, that driving cycle change that I talked about, with the last one that we offered, that running on IC engine in city traffic and switching on to EV on highways, we got this results of fuel consumption. The conventional IC engine vehicle was giving 4.65 liters per 100 kilometers on state highways. The second set of testing, which gave about 4.83, this was Tarapur, Anand Tarapur, this was Anand Dakor. And national highway, it was 5.505. As I said, on high speed, on highways, the fuel consumption is going to be higher, which is where we need to shift in EV as compared to city driving or stop and go driving, where it can be run on IC engine and it can be shifted to high speed running on EV, which will give the better benefits. And expressway, it was 5.12. You can see the national highway 8, it was 5.05 liters per 100 kilometers, whereas expressway, even you are likely to drive at a faster pace, 5.12 liters per 100 kilometers. As against that, the EV mode, it was 2.29, it was 2.62, it was 2.19 and 1.97. The higher consumption is the better performance here. So maximum speed achievable with electric mode was 62 kilometers per hour. This battery was particularly lead acid battery, 150 ampere hour. You can imagine how bulky it was and how heavy it will be. Whereas if that changes to lithium ion or high density, energy density, lightweight batteries, the performance will be even better. So under the same state highway condition, the performance was 50.8% improved. The state highway another 45.8%, and national highway it is 56. Expressway it was 61.5. And if you see these figures, 4.65, though according to corporate average fuel efficiency norms up to 17-18, which was 5.51 liters per 100 kilometers, which is complied by this, but phase 2, which is 4.78 liters per 100 kilometers, which is very difficult for this IC engine conventional vehicle to comply, and thereby hybrid electric vehicles will be able to overcome the compliance for norms set out by government. So this is what I said, I already talked about. Peak performance with existing ICE driven is retained and assured. Existing 12-volt electrical system is not disturbed. Yes, this existing electrical system was not disturbed. and hydraulic brake pipes utilized for disc brake in rear. Same hub drum brake was used for disc brake. No changes in suspension, no additional instrumentation required. Power steering AC are driven by ICE. Hence, ICE has to run on idling while running in EV mode. So what I would say is appropriate torque capacity of BLDC hub motors can be selected for particular vehicle configuration. So depending upon the size of the vehicle, depending upon the GVW of the vehicle, and appropriate torque capacity of those days, 2008, there were hardly any motor hub motor manufacturers, or even electrical motor manufacturers for automotive application were available. Today, there are n number of automotive motor manufacturers, and even you as professors, you can design your own, and even the softwares are available. Various kind of softwares are available for designing motor for the required torque capacity, which can be adopted for converting the existing vehicles into hybrid electric vehicles. The advantage of hub motors, though it was low torque, low RPM motors, output is directly driving the wheels. Hence, the motor efficiency is the only loss. Very little, I mean, like absolutely no loss. There is no, motor is driving the wheels directly. So, avoidance of excessive weight increase can be helpful. Geared hub motors can add varying torque speed requirement. There can be the hub motors can be geared, and then the output can be given to the wheels. Well-to-wheel energy efficiency of prototype hybrid electric vehicle was 1.45 kilometers per megajoules, as against 0.64 only for inside the hybrid electric vehicle of Toyota and I think Nissan, and 0.56 for Prius model. The conversion that we have made, it was 1.45 kilometers per megajoule, and Tesla, it is 1.14. I'm talking about a Tesla model those days available to compare with. So proposed method is expected to reduce the fuel consumption, results obviously further for possibility, but easy to implement. Routine service. I will rush up now. I think my time is getting running out faster. These were the, I had filed a patent, finally did not pursue further. Then there are two publications. Challenges, I think the other speakers would speak about. I would like to go to Dhaval. Can I know how far I can continue?
So now, you can continue 5-10 minutes more.
Pardon?
You can continue 5-10 minutes more.
Hello, how much?
5 or 10 minutes. 5 to 10.
5 to 10 minutes. Okay.
Yeah.
All those things will the other speakers, I think they will take up, but I think nobody else will talk about vehicle dynamic considerations for effective vehicle design. So I will go to those points. I will skip this history as well. Fundamentally, the vehicle dynamics performance is considered as motion accomplished during acceleration, braking, cornering, and ride performance, including handling. So we will talk about for electric vehicles, mainly what is important for you all is acceleration, braking, and cornering. This also I will skip. So kindly note that the first, the vehicle designed to begin from inside out. So no passenger, number of passengers and load to be carried, ride comfort, fuel economy, performance. These are the first thing that you should decide. And then max speed, max acceleration capability has to be identified first, that what do we want vehicle to do. and then selection of tires according to that, and drivetrain will be actually decided based on point 1, 2, 3. So to begin with, vehicle dynamics performance basics, static load, that is W, the vehicle, if we weigh front axle weight and rear axle weight, WFS plus WRS is equal to total vehicle weight, and dynamic load is same vehicle weight, front axle dynamic weight and front axle rear axle dynamic weight, WF plus WR. And as you know, Newton's second law of motion, that is force, the tractive force is equal to mass into acceleration. So if you look at this tractive force is forward longitudinal. Sorry. This axis system, SI axis system is considered as fixed onto the vehicle, and the tractive force is considered as tractive force considered a positive x-axis towards front, and vertically down is the load on the vehicle, and y lateral outside right is the lateral force for cornering. If you look at the first step is analysis of dynamics loads. What are the loads that are acting? That is, this is front axle weight. Static WFS is equal to WC by L. WRS is equal to WB by L. How does it arrive? We take a moment about B and then we take a moment about A, both being in equilibrium. When we resolve this equation, then you will find WFS is equal to WC by L and WRS is equal to WB by L. Now this is an aerodynamic force that is acting at the front of the vehicle. Then this is the vertical load. This is rolling resistance that is acting at the contact patch area. This is the tractive force which is acting at the contact patch area. This is the rolling resistance at the rear axle. This is tractive force on the rear axle. And if the vehicle is moving on a gradient, there is a component of W sin theta which is acting against the driving force. So that is why when we consider the tractive force required, we need to consider the weight of the vehicle, effect of inertia forces called D'Alembert force, that is equal to W by G into AX. This is dynamic force that is acting when the vehicle is under low speed acceleration. So dynamic load on front axle becomes WFS minus W by GAX H by L, whereas the same load is getting transferred to rear axle when the vehicle is accelerating on a plain road at low speed. Then WR, that is dynamic load on the rear axle, becomes WRS plus this D'Alembert force, that is dynamic load on the rear axle. And the next thing that I would like to talk about is the power to weight ratio and acceleration. I always advise all these vehicle students and designers that use lightweight material. Use lightweight material and shed extra weight wherever possible. Even a longer bolt is going to contribute for the performance on the vehicle in terms of acceleration and speed. Now, high speed performance of the vehicle and acceleration is based on power to weight ratio. If you see, this acceleration is equal to this constant 550 by G into G by vehicle speed. The lower the speed, the more the acceleration. If the vehicle speed is higher, you cannot achieve the maximum acceleration. But power to weight ratio, this is what is in your control. If you increase the power with the same weight, the acceleration is going to be better. If your weight is increasing with the same power, then your acceleration is going to be lower. So power to weight ratio is going to control the acceleration for the vehicle. See, if you look at 10 passenger cars, 10% of passenger cars, the power to weight ratio is 40 pounds per HP. The performance of acceleration with respect to gravitational acceleration, like acceleration of vehicle in terms of G, that is 0.3 G is the acceleration that can be achieved at 30 kilometers per hour, 32 kilometers per miles per hour for passenger cars with power to weight ratio as 40. This is called as power to weight ratio, but it is weight to power ratio, which is 40 pounds per HP for passenger cars. Whereas if it is trucks, that is 250 pounds per HP, the acceleration that can be achieved is only 1.15 G. So for powertrain, the important thing that designers should consider, the driving force, tractive force Fx is equal to torque at the engine or torque of the maximum torque of the motor. Then NTF, that is multiplied by torque of the motor multiplied by NTF, that is combined ratio of transmission and differential, and then multiplied by efficiency of transmission and differential, that will give divided by rolling radius of the vehicle. Correct? So that will give you the driving torque, which is what will be depending upon W by W into mu. That is mu W is the actual tractive force that you require, and that can be derived from this formula. Next point that is important for you to understand is constant deceleration to achieve for stopping distance. If the vehicle has to stop, then it is derived at V0. The initial speed from where you want to stop the distance is that stopping distance is equal to V0 square divided by 2 dx. That is dx is 0.25. I mean deceleration in G. Okay, so that is where if you look at V0 square by 2 dx, it means what? The stopping distance is proportional to V0 square, and stopping time is equal to V0 by dx. It is proportional to V0. It means the stopping time is proportional to V0, but the distance is proportional to V0 square. It means from initial speed, when you are stopping, the distance is not going to be same if the speed initial speed is 50 kilometers per hour or 100 kilometers per hour, and that is where all the accidents take place. So this performance parameters will be better off. However, this is for the conventional, this calculation is for the conventional ICE engine vehicle, but this performance parameters will be better off in EV as compared to ICE, because magnetic field of stator and rotor will decelerate drive components, which please you need to, somebody has to work out, and like there can be very nice paper coming out of this on this topic. Similarly, the all four wheels should lock simultaneously. That is explained here. We will skip this. And maximum braking force is dependent on mu, that is coefficient of friction between the road patch, depending upon the W, that is the front axle weight and rear axle weight. For EV electric motor, again the same statement that I have made. The fields, magnetic field of stator and rotor will offer retardation through the driveline component. That is to be considered. Aerodynamic force we will talk sometime later, I think, for this. And rolling resistance is important. If you look at rolling resistance, the tire drag with the temperature rise, okay. Temperature rises when they start the vehicle running. It goes maybe right up to 80 degrees Fahrenheit, and the initial uh, tire drag, rolling resistance, which is so high, which is becoming lesser, and with the higher at a particular kilometers per hour speed, it becomes flat. But rolling resistance, which is the steady at all the speeds, whereas aerodynamic drag becomes equal to rolling resistance at about 55 to 60 miles per hour speed, and then it is parabolic, so it increases proportional to v square. The function is v square. So aerodynamic drag is proportional to v square. So it goes on increasing. Total road load, that is what is important for you all to consider, which is to be over driveline motor, and that is why the power consumed by road load is about say from here to up to 75 horsepower is consumed by the road loads, which is to be overcome only then where vehicle will be kept running at 100 miles per hour speed. Almost 75 horsepower is consumed by road loads. That includes rolling resistance, weight of the vehicle, and aerodynamic drag. So road loads have direct impact on the fuel efficiency, which is again dependent on the driving habits and drivers' traffic conditions and many other parameters, loads and tire temperature and everything. So these are the references I have considered. That is Vehicle Dynamics by Tom Gillespie, CM, lot of this thing references. Again, I will come back to the same statement. If you take care of nature, nature will take care of you. That is by David Attenborough. And one more request to you, that you are all in electric mobility field. Apart from research on various intricate details of EV and HEV, participation in EBAHA for your students is that EBAHA event of SA India. It gives an opportunity for electrical and electronics, automobile, mechanical students. If the faculty members take interest, there is a lot to learn and scope for research for the faculty members as well through participation in EVA SA India. The registrations are open. You all have any queries on this, you can talk to me. You can get my email and contact address, and then I feel that if more and more students will take part, the students will get ready for industry. And sir, the industry, as I said, all these 2 hours, that is going to be automotive industry, is going to be electrical e-mobility industry. Sir, that's all from my side. Sincere thanks to Dr. Hardik Shah, Kalpesh Chudasama, Professor Dhaval, Tailor, Jigar Mistry, Dr. Vishal Singh, Principal of ADIT and top management of CVM, and all the participants. Thank you very much.
Thank you very much, sir. Thank you very much, sir. Now, participants, if you have any query, you can ask. Otherwise, we are going for a break, and we will start our new lecture with 2:30 to 2:35 around. Please ask if any query to sir.
As well as we will share the session 3 link in the group also, so you can directly join through this link.
Third lecture link will be shared in WhatsApp also, and you can directly join from MS Team also.
So any questions?
So a small point, sir. So between the lecture, we should have 5 minutes break at least between 2 lectures. We should need some break for 5 minutes between 2 lectures. It's become 4 hours to getting concentration becomes very difficult at one stage.
Sorry to interrupt you, sir, but actually it is a first session, so there may be a complex, like we have to inaugural session and everything. That's why this issue is created. But from the tomorrow we will take care about same, sir.
Thank you, sir.
Okay.
From tomorrow, you can see the schedule. We have kept a 1 hour break.
Any questions in the chat box, Dhaval sir?
I will
Just check.
There is no query yet right now. So sir has already given you email. So if any query, any participant, you can directly contact to sir. He will.
I would be ready to help. I am a retired professor and working for the society with any kind of queries or help required. I have a good clout and among the industry as well, and you can
So you
also
can directly contact to sir if any problem. Thank you.
Yes,
thank you very much. Thank you very much.
Okay, thank you.
So right now we are keeping a break of up to 2:40. We will start from 2:40 onwards. Thank you.
Thank you.
Now, Dhaval, can he take or some?
Yes, sir.